Hey, and we're live. We did it. Fantastic. Let me, hey, and we're live. I did it. I'm here, everybody.
Woo!
Fantastic. If you haven't already joined the Discord, it's great. Links in the description or the About section or wherever you think the link should be. They're probably there. What are we doing today?
I don't know. Are you waiting for me to explain that, or?
I was waiting for anybody.
Well, we'll talk about a compiler rewrite, a pretty big one, and then we'll talk about some C++ stuff that might come in handy for rewriting the compiler.
Sounds pretty accurate. Yep, it's the rewrite talk. Not the talk, the action. The talk's been done.
That was last stream, good God.
That's right. Good God. You know, that has a 5.46% click-through rate. So it did great.
Interesting.
My gray thumbnail was very appealing.
So, how do we want to start?
I'm going to answer a question in chat. How did you get Windows Media Player working on 10, Lens? I didn't. I'm using VLC and Project M plugin. So you can look into that if need be. I might just leave this here for a little bit. It's kind of fun to look at. Anyway, yeah, I say we get right into it. Fartingle says, "Are you O-cameling now?"
I will say, since the frame rate is so low on Discord, this is a bit nauseating to look at.
That's fair. I'll move it away. It's fantastic, though. Ooh, pretty. I could watch it all day. Humans are simple creatures. Oh, that's Izidayush. It's so good to see you, Izidayush. I feel like it's been a while. Highlands.
Probably should pull up the stream chat as well in case there are any questions I can answer.
Yes. Oh, I also haven't fixed the chat window, so I'll do that now.
I'll pop up the chat now, otherwise I'll end up looking at your stream again. I'll be very confused.
Something has went wrong.
Here we go. That's better.
Okay. Fantastic. I'm very good at OBS, I swear. Okay, so the idea is... it's been a while. It's been a long while, hasn't it? It's been like over a week.
It's been 2 weeks, basically.
Oh, since the last stream, yes. Just in total stream time on the compiler. I'm pretty sure it's been over a week of stream time. Which is, like, if you add up all the videos in the playlist. Which is, it's a lot.
Not negligible.
That's right. And I'd say that at this point, I'm pretty proud of where the language is at and what it can accomplish. You know what I mean? Like, we have a compiler that can compile basically almost any program we give it and only like have bugs come out on like 50% of them. For me, having done that and having written this, that's incredible to me because there's like 20,000 lines of code here. I could have screwed up each one of those. Even if I didn't write it, I can come in and screw it up. I've done it plenty. So I'm just happy we've gotten to where we're at. And I think that it's a full compiler at this point. There's nothing it's missing.
Pretty much, yeah.
We could, in every direction, upgrade things at this point. It's kind of like a hobby car. We've worked on it to the point, and it like runs now, and it kind of runs shittily, yeah, and it breaks down sometimes. But that's okay because it's your hobby car and you're working on it, right? And you'll slowly upgrade it. But the thing is it's like if the frame you're using starts rusting and it's terrible, you'll probably switch out the frame, right? And I think that's kind of what's happened to the code base.
That's true, yeah.
It's no longer it's it's literally been rustified. No, no, it's just been the fact that it's no longer pretty code, and it's no longer even, we're not doing things that are low level anymore. You know what I mean?
No, far from it.
We are interacting with low level things like assembly, but we're not doing it in a low level way from assembly. There's no need to do that, right? And that's what C kind of is. It's a low level way to access things, and we don't necessarily need that for the compiler right now or anytime, because we have a whole compiler now, and pretty much every part of it is like it's you can do it in C, but it's like, for example, here the x86 64 object file backend is 3,000 lines. It definitely doesn't need to be. There's just a lot of I don't want to say duplicate code, but very identical code that could be easily merged if we had templates.
Yeah.
Like, this is ridiculous because we have like immediate to register, and then we have like, oh, switch on the instruction and then do different things. And
I'd just say isn't, but what is if you scroll up a bit more, it's
yeah,
mainly if you look at the no, not that far, just 2 lines. If you look at the similarity between case R16 and case R32, that's the main thing that I'm noticing here. If you scroll down a bit,
this bad boy.
If you just look at this, just from a far away look at case R16 and case R32, it basically looks like the same code.
That's exactly what I'm trying to say, yes. And the same for R64 down here too. It's very similar, just with the if missing. And there's no reason it doesn't need to be there.
What's actually different? I don't see any difference.
I'm pretty sure the only difference between 16 and 32 is that 16 has an extra prefix, and 16 encodes 2 bytes, whereas 32 encodes 4 bytes.
Yeah, so the 32-bit is the default, so it's OX69/R, and then an immediate double, which is 4 bytes. Double word, right? Because it's Intel stuff. And basically, R16 is just the same thing, except with a 2 bytes, right? Just one word, immediate. And then it actually uses the OX66 prefix to drop down the 32-bit instructions to 16-bit. And this is used everywhere all the time. So you'll see this OX66 emitted in the machine code directly before an opcode. Lots to make a 16-bit instruction or a 2-byte instruction. And then for 64 bits, they did the same thing, just the other way. So now there's what's called a rex prefix, and that's just a byte that has some bits in it that mean some things that just extend the register bits an extra bit. And then you can just encode more registers because now you have 4 bits instead of 3. That's literally all it is. And then the W means that it's not just, because a rex prefix, there's like multiple types. The W means that it actually will promote this instruction to 64-bit operations.
Okay.
And this is still takes an immediate double because Intel likes to just screw with everybody all the time.
So yeah, this function should really just be one function call that takes the OX69 as its only operand. This entire switch case.
Exactly, yep. And it'll just be so much simpler.
Yeah, and the problem is that it's not just here. It's this file.
It doesn't stop.
A copy of this file in the assembly backend. Like they're the same file. Just one emits bytes, the other one emits text.
Exactly.
But the logic is the same.
Yeah, that's very accurate. And when I change something in one, I change it in the other. It's terrible. It doesn't stop.
Yeah, it doesn't stop. So that's an issue with the code base, is that it's just grown not even complex. It's just there's a lot of code and a lot of duplicate code. There are some architectural problems, like that's just logical, that has nothing to do with programming language. Like Sema is a bit scuffed right now, and there's a few things that can be improved and that we're going to improve, and that has nothing to do with the programming language. It's just that in addition to that, there's also just these problems here, which are just overbearing.
I see.
Is it he says professional OBS engineer senior LensInix. It's actually called Lenser OS, but thanks for asking. Those indents, I don't think you're able to ever commit code to the Linux kernel. I've committed C styling atrocities. Ruark asks RIIR. I don't know what that is.
I will say there's two somewhat
Rare.
trivial things I'm recommending for the rewrite. One, for space indent. The second one is using Clang format.
Yeah, we may do that.
Yeah,
then everyone
because
can do it themselves. But
formatting is also slightly annoying. That's the least of our problems, but still.
we made it to the end finally. I think that was like 2 minutes of scrolling.
I saw some lines wrapping.
Yeah.
Oh,
Probably.
oh no.
Jesus
Yeah, there we go.
This look good.
There's lots going on. It's a very extensive
Again,
backend.
like most of this is just why these lines are so long is you just have accesses of deeply nested things.
Oh, I see.
Yeah. Well, basically, we're saying this is tough, but we're saying that if we get a machine instruction that's a Leah, then we switch on the operands. So this is basically a big switch, but we can't switch on different
Inside a
function result values because we have to pass different things to different. You know what I mean? There's no switch that works this way, so we have to use an if else function. You know what I mean? Type of thing, and it becomes very messy because we just have to say if MIR operand kinds match these, if MIR operand kinds match these, and there's no reason that these shouldn't be like grouped into one thing, where there should be like an MX64
structure you can do here.
Yeah.
But a lot of these is going to be cleaned up a bit more once we move to C++, because we'll just throw a bunch of state into member variables, and then you don't have to prefix them explicitly and stuff like that. You don't have to pass them around everywhere. So, for instance, you're passing instruction into everything here.
Exactly.
Or
Instruction.
context or stuff like that.
Yeah. And that's just for the emission stuff. Okay, refactor or rewrite?
I was going at least with refactor initially, but at this point, it as local really said, it is really a rewrite, pretty much.
Okay, it's labeled as a rewrite, but it's the action of a refactor. We're not going to like delete code and restart, but we basically are.
Well, basically, yeah.
I mean, we are going to delete code and restart just one part at a time.
Yeah, well.
I mean, half of it, but you know.
The semantics are blurry. It's a bit of both.
It's exactly. Maybe rewrite in itself. Yeah, it's not ready for that. Once we do this rewrite, in a year, it will be ready for that.
Oh, that's optimistic.
Maybe 10 years. Because
I think a year is doable.
In a year, it's doable depending on how many people like work on it regularly. Because I have time to work on it now, I will not have as much time to work on it comes like October or something.
I'll have more time come next week.
Mr. Mugame, it's your fault you're on Linux. Mr. Mugame says, rewriting takes exponentially less time with every rewrite.
It does.
What did Ruark say? I missed it.
Wait, so the compiler is still going to be be functional throughout the rewrite, or
probably not. That would be a nice structured refactor, which is why it's a bit of both.
Yeah.
When you say refactor, that's what I understand.
Yeah. That's why I don't like the term refactor here, because I think it would take us entirely too long to do a full pure refactor where you're only ever changing things and never like rewriting them.
Yeah, that's absurd. Simply because if you change the IR, you have to change all the backends too, because the IR is used by the backends.
Exactly. So it makes more sense to like half refactor, half rewrite a section, and then get it working up to that section, and then move on to the next one. So rewrite the Lexer parser by refactoring our existing code. Cool. Rewrite semantic analysis by reworking the existing code. Half and half refactor, rewrite step by step until you get to the end of the compiler again.
So, speaking of, should we get about talk about some of the details of the rewrite, or
let's go?
Yes.
Okay, what do we start with? The general plan. I think I've explained that. We talked about that yesterday. But for the people that are watching, the general plan is simple. We start with Alexa, rewrite that. That's trivial because Lexes are trivial. Then after that, we have to do the AST and the parser. That's going to be the hardest part of the front end because Semma is so simple for us. Once that's done, we can print an AST and see if that's working. Then we can do Semma. Once that's done, we can print a type-checked AST and see if that's working. And then the next thing is to redesign the IR and the code gen front end, meaning IR generation. That's also going to take a while. Once that's done, we can simply update the LVM backend because that's really simple, and then we can at least generate code and compile code again. And once we're at that point, we're going to fix all the bugs that we've introduced in that process. And once that is done, we can start working on the assembly backend. Probably that's what we're going to do first. And once that's done, then we can either do the optimizer or the object file backend because those are mostly optional components. And once those are done, then we'll be where we started, but hopefully at a less scuffed way, and also with some logical overhauls.
And we briefly discussed the option of slightly changing the semantics of the IR and stuff to better support other languages as front ends. Probably won't be doing a whole lot of other language front ends on Lens's streams, but I might start streaming my work on the Intercept compiler in context of Laye.
Oh, there's a raid. We got a raid from TCAP1. Thank you so much, TCAP1. Great to see y'all. We're talking about a compiler rewrite, and we're going to go to C++. We're going to make an AST that's not type checked. It looks like this in the rewrite. We're going to start with this, and then we're going to go to a type checked AST, which is a little more complicated, has all the types, and everything is filled in, as you can see. And then we're going to go to the IR, right, as you said? We're basically going to go in order that I did on stream, where it's like, write the Lexer and parser, write the Semma, write the IR. And then we're going to work on one backend, the x86-64 backend, which has lowering to do in the IR. We may move things around. And then it has the MIR, which we may eventually want, but we may want to... We'll think about that. Do we want to go straight to MIR?
No.
We want to just go IR to assembly first, right?
No, we're gonna do IR to LVMIR, then IR to MIR to assembly. That yes.
Right.
Because
so yeah.
I forgot about instruction selection. I left that out. IR to MIR to instruction selection to assembly.
MIR, yeah. Instruction selection is part of MIR.
Yeah, basically.
Because this is just IR.
Yeah. This is like IR represented as MIR.
Exactly. Yeah. It's generic MIR. I don't even consider it MIR. I would call it like GMIR. Like this is general MIR.
Yeah, sure.
Because this isn't machine instructions at all. And these aren't registers.
Format with IR instruction, every instruction is a separate type. With MIR instructions, there's only one instruction type.
Exactly.
It's going to be a lot clearer when we do the rewrite. So,
I'm so excited.
I think the main architectural thing to think about that isn't just implementation stuff is AST and IR layout. And the IR is basically just an AST with two levels, functions, blocks, instructions. So we might as well just talk about the AST first, because whatever we talk about there is going to be one-to-one the same thing in the IR, because it's also just an AST.
That makes sense.
One little difference, perhaps.
So what's our current AST setup?
So our current setup is we have a tag union, and by union I mean literally a raw C union.
So a tagged union means that we have an enum, and that enum basically just is a name. It's a number, but it's just we store this number and say like this semantically means that whatever we're storing in the following union, which is, oh dear, within node, whatever we're storing within this union is corresponding to that type. So for node root, then we would have the node root populated in data, and we would access it through root. But there's nothing stopping you from accessing it through another one, which is really bad.
That's one problem, but that is a problem, but that is the least of the annoyances that comes with this. There's two main things. Well, okay, there's two main reasons why unions are not the best approach for ASTs, and one is simply a performance thing. It's that the size of a union is the size of its largest member. Meaning, if we have, for instance, some random complicated node that is 400 bytes, then now every node is at least 400 bytes. That means a single integer literal is 400 bytes. That's not good. That's a lot of overhead. And you might not run out of memory if you have a lot of memory, but it's going to slow down the compiler because it has to just shuffle around heaps of memory all the time. So that's one part. The only benefit, and that's literally the only benefit you get from unions, is that they have the same size, so you can replace a union in place. If you have like a call instruction node, you can reuse the same memory for like an if expression without having to reallocate anything or free anything. That may seem useful, but it's only really useful if you're like deserializing an AST or stuff like that, and that's not like the primary thing that we do. It actually turns out that most of the time you're actually just replacing a node with another, and that typically entails just replacing a pointer and not just overwriting the node, because there may be other references to the same node and stuff like that. So as it turns out, the only functionality you get from units is actually fairly useless most of the time. And the drawbacks are just too big. Is the performance one, then there's the other one. And that's with a union, there's no way of really telling that something is an if expression or a call expression in terms of the type system. There's only nodes. You can't pass an if node to something because then you're missing just the common data. Whereas if you have an inheritance-based hierarchy, you can have an if expression pointer, and you can still pass that around as an expression pointer because that's the base class. But it also, in the type system, you know that if something returns an if expression pointer, that thing is an if expression.
Yes.
Yeah.
Raticide in chat says rewrite in Rust. Yeah, maybe in if you want to do that, you can. That'd be cool. Taper says compiler dev as well as raid and puts up some awesome emotes. I gotta show him. Look at that. Look at that flexed cat. That cat is strong as shit. Bet he could beat you up. TCap1, the raider, says I was pretty much streaming the same thing, compiler for fun, PogChamp. Hey, there's another one of us.
One of us.
We should all merge our compilers and make our language is all just one big compiler.
I've already explained that. I would add mine as a front end, but the problem is I use LVM profusely, so we'd have to do the same, and you probably don't want to do that because you can't build LVM on your system. So
I am getting an upgrade soon. Also, I just want to shout out Jblo Hairline, TCap1, the Raider, and Azenris for following. Thank you so much. I appreciate you, TCap. Is it? I hope I'm saying that right. I'm so bad with names. Anyway, yes, C++, rewrite, us.
Yeah.
Basically...
yeah. Okay, keep going.
Yeah. Basically, we have this parser, and I started it, and then it's been finished, and I'm not sure that that's the most ideal way to do things, because I didn't have the idea for, like, the macro system or know how that's going to work when I started writing the parser. And in fact, my parser is long gone. The first one I wrote is long gone. This one is one Saraid has written, and then I've massively botched with my code and interjected. And it works, but it's also just like, again, the node pointer, we have a lot of wasted memory, which isn't really a big deal nowadays. But the biggest deal is that it's just hard to work with, and
Yes.
there's so many bugs that are caused just because, for example, here's the thing, like if you have a call node and it's like 18 bytes and the last byte is a flag for something, and then you have an if node that's 32 and you switch it, but that last byte was set, you're going to assume that it's 0 because like, oh, I didn't set it to anything, I just switched it to an if. So you have to go through and set all the old union values to 0 or to something reasonable where they will show up in the next one. Or you just have to go through and set every single member every time you change the type of something. And at that point, it's like, why aren't they separate things, like you said? So yeah, there's no reason. We can just make this better.
Yeah, and I will say architecturally, the parser is probably the thing that has the least logical problems. Like the parser, the architecture of the parser is fine. It's the AST where the problems are. Like the parser, I'd say, is I don't plan on refactoring anything or like just changing anything in the parser really logically. I haven't looked at it in depth in a while. Maybe there are some stuff, maybe there's something that's scuffed. But I'm not really planning on changing anything major there. Because the parser, I think, is fine the way it is.
Just the data structure it interacts with.
Yeah.
And all the strings and.
Obviously, yeah, but that's going to be fixed. Like the memory leaks we have memory leaks everywhere, but that's fixed automatically by moving to C++.
I love
you
that.
have to write absolutely horrible C++ to ever get memory leaks. So
it's true. GMOSX says, hello, what are you working on? We're doing a compiler from scratch for fun. And we're just basically, we're going to start it from scratch again after 64 episodes and over a week's long worth of playlist content. It's going to be.
I would suggest starting the second playlist.
I'm definitely gonna keep adding to the first one, but I'm also gonna start a second one, I think.
Okay, yeah, sure, that works.
Just change the title from C to C++.
No.
Writing a compiler in C++ for fun, sure.
Yeah.
By the way, I have a question about the AST. So what are you guys gonna do now? Is it gonna be like a class hierarchy, and how deep is it gonna be?
Deep.
Okay.
Deep, like as deep as necessary, because it simply makes, like, for instance, in this language, everything is an expression, pretty much. I don't think we really have statements.
We do not.
So we only really have expressions, so the root of the hierarchy is just expression.
Okay.
And then more or less every node is a class with some abstractions. So for instance, we can, like, some nodes only have one operand, so we can use an intermediate base class that handles the common code for things that have one operand and stuff like that. That's like, you'll see it automatically as soon as we start writing AST nodes and we have code duplication between nodes, then we can just merge them into a base class.
That's fair. Okay.
Bartingle said the Flintstones if they were programmers.
Do it again. Yeah. I had another auxiliary question because you brought up what if we merged our compilers together? And I was already talking about writing a second front end for Laie.
Yes.
What is your opinion on calling the compiler something other than intercept and just having intercept be the name of your language front end?
Yeah, I've actually been thinking about that. It started as like everything was one thing because it's all in the same repository. And like designing the language happened as I was writing the compiler code.
Yeah.
So it used to just be intercept, but you're right. It's no longer like we can just add another language front end. It's no longer intercept specific. So
I recommended LCC in the general chat for the Lenser compiler collection.
LCC.
How
that would be an option.
I'm fine with that.
Sounds good too.
Is it used? I mean, it's like
I did a sudo apt install LCC and it doesn't exist. So.
Well, now it does. You just said it.
I haven't Googled it.
Found something.
Yeah, I Googled it. What'd you find?
Lansing Community College.
Well, it's got to be programming related.
cc.edu.
That's okay.
That's probably
I'll sue
fine.
them for taking my name.
You're not in
I'm
the same
currently searching
field, so it doesn't
DNF.
matter.
Let's see what comes up.
Lenser, Lansing, I mean, it's clear copyright infringement.
There's so many colleges. Lower Columbia College, Lane Community College,
This is
Well,
Lenoir
community
Community
college,
College.
Okay, there's
Okay.
no package called LCC in the Fedora repositories either. So.
Yet.
Yeah,
And
so then you're probably fine. Go ahead and do it.
and I don't see bad stuff come up if I look up like terms next to it,
Me
if you know what I
neither,
mean.
yeah.
CC.
That's good. So that's my recommendation.
I would go with LCC. It sounds like GCC, which I very much am inspired by. And yeah, it's a community collection of compilers.
Yeah, and I would love to encourage that in community write your own front end thing, because one of the things when I was learning how to dev languages that I always wanted to do was just build on somebody else's back end, because I wanted to get a language that worked really fast with my own syntax. But like I didn't want to write a GCC front end or something, right? I didn't want to like learn all of the really complicated compiler stuff. So if we kept the core concept of this compiler simple data front end too, that might invite more people into the compiler writing community for contributions and stuff. I don't know.
I agree.
Wait,
yeah.
is it a myth or is LLVM really that complicated?
LLVM's
really.
LLVM's that complicated.
Okay.
It depends on how you look at it. I'm pretty sure the GCC code base is at least generally considered worse to work with than the LLVM code base.
Okay.
LLVM, doing anything with LLVM is, once you understand like the couple LLVM idioms and conventions there are, is fairly intuitive. And LLVM is also designed, it was designed and is designed to be reusable in parts, whereas GCC is just a compiler with, I think, global variables and stuff like that everywhere too. So.
Yeah.
That's a good point.
GCC was not
you just said it so well.
Designed to do code.
GCC is just a compiler. LLVM tries to do everything in existence.
For writing tools, for everything. Like
it's
if
terrible.
anyone wants to use some tool to do some transformation on C or C++ code, they're going to use LLVM.
What you're describing is complexity.
Yes, but also it's useful complexity.
I agree. I'm not saying it's unneeded or that LLVM is bad because of it. It's just hard to understand because they don't even write documentation for it. So
that's true.
Yeah, it's not really. I mean, some parts are well documented, but with things like the AST, you kind of just have to look at what little doxygen documentation there are and see, okay, what can I call with this? At least every function has like at least a comment that explains what this does, more or less.
Whereas GCC, I've like built cross compilers and edited complex, like made new backends and stuff like that. And I did not know what I was doing at the time at all. I didn't understand any of this stuff. I was just like,
GCC is not even supposed to do the. Like, I recently read this was someone summarizing a conversation between Stallman and a bunch of other people about using GCC to do semantic analysis in Emacs. And Stallman said that he, under no circumstances, did he want to export the AST from GCC and make it externally available, because he just doesn't want anyone to be able to use the AST. That's for some reason very important for him. But LLVM just does that. Everyone just uses LLVM's AST, or Clang's AST rather. So it's like the exact opposite of GCC in that regard. It's designed to be easy to use, or at least it's designed so it's possible to use it at all. Whereas for GCC, it took a long time for GCC to even allow plugins, and what they allow with that is also limited.
Yeah,
so
compiler plugins in general for GCC are not up to date.
Yeah, and LLVM plugins are as easy as you just call the damn thing.
Exactly, yeah. LLVM is much...
Yeah.
It's basically like the modern C++ equivalent. It's more complex. It tries to solve every problem you might have. And if you have a shitty computer, you just can't run it.
Yeah.
There you go.
So if you're poor...
Yeah, so if we could have a... Sorry, you go first.
If you're poor like me and you're saving up for your computer upgrade still, since 2015 when the prices went up or something, and basically it's just undoable. It's not even a choice. because I've tried.
Yep.
I'm like LLVM. At this point, I don't care. I'll just use what works. But LLVM doesn't work for me. I can't get it to work.
Yeah, me too.
So that's okay. It's too complex. It's hard for me. I'll use GCC because it's simple. I can change the code. I can read it. It's complex and it sucks, but it's gonna get better over time. And I like the FSF and the idea behind it. So it works out. Ideally, LCC will gain a C front end, and then we'll just kind of go from there.
No, ideally,
I mean,
the
like I
final
said, I want to
solution would for it to gain a C++ front end.
Oh no!
But that would take would take literal years of work. So
yeah, it would.
Yeah, like I said
Parser.
yesterday, I do want to write a very simple C front end just to have it, so we don't have to rely on LLVM for simple C file integration. So, like, honestly, we could do like a TCC, very small, special purpose C compiler front end as well for the LCC.
Just the preprocessor is going to be a lot of pain.
It's like getting a standard compliant preprocessor is funky, but it's not like the worst thing.
It's doable.
How I would do the preprocessor is the same way that Clang does it. Clang has one preprocessor and then one Lexa instance for every file.
Yeah.
That's how I would do the preprocessor.
If I were to write it, I'd probably end up doing it like TCC, where the Lexer is the preprocessor, but that might get a little complicated.
I think that makes sense.
Yeah, but the preprocessing is probably not the worst part about C.
Nah.
No.
Anyway, again, standard compliant preprocessing is funky, but doable.
Fartinkle
said, so I'd love to tackle
it. Fartinkle said, can't even build it on mine. One and the same. How do you want to compare HTML with LLVM? Ah, yes.
Interesting.
So then I guess another question that comes in here is, how do you want to architect around plugging in front ends and back ends? Are we just going to support statically linking and you'll have to rebuild the compiler for a new front end or back end? Or are we eventually going to be like, yeah, you can bring your own DLL or SO or whatever?
Yeah, well, there's two different things. There's plugins, compiler plugins. That would be DLLs that are just loaded by the compiler by some API that you'll pass on the command line.
Right.
And the other one is just adding a front end as a library. In that case, it would just be a matter of turning the compiler into a library and making the driver a separate executable, which is definitely doable.
Right, yeah. So then compiler driver, probably. I think compiler driver should be the first thing we try to tackle because that just sounds way less complicated.
The driver is the thing about the driver is that it's pretty much useless without anything behind it. We can definitely architect this like from the get-go. We can architect it in a way that the compiler proper is a library and the driver is an executable. That's easy. We can do that. We should probably do that. That's a good idea. Yeah, sure. But that's not. That's pretty simple. Like the hard part is stuff like the AST, which we should be talking about.
Yeah, I just wanted to make sure that question was asked before we get halfway through the refactor rewrite and we're like, oh, well, now we have to refactor it to support it as a library instead of as an executable, right?
No, I would definitely design it to work as a library up front.
The idea is also to separate the reaching between the layers.
Yes.
Which I did.
So like the library itself would basically be the entire middle section with the IR and the optimizer, and then you'd plug in with your APIs and stuff to the front end and back end.
Sense, yeah.
Yeah. The GCC way.
Sure.
That's actually what's required by the if you're going to link with something under GPL. Is that you can switch out the library with another one, and it'll work just the same, given you follow the API.
So if I understand this correctly, so basically LCC is just going to be an LLVM, pretty much, that you can link with your front end.
A very light community-driven.
LLVM that doesn't suck. Yeah, the tutorial isn't going to be the stupid Kubernetes confusing BS.
Yes, yeah, that tutorial is a bit strange because it's not a good tutorial because it also goes over stuff like AST design, which if I made an LLVM tutorial, I would just not talk about that. I would assume you know how to do that because if you were looking for an LLVM tutorial, you're looking about how to generate code. If you don't know anything about the compiler, you should not be starting with LLVM.
Probably.
Especially not with the LLVM tutorial.
We are the
If
15th.
you want to learn about compiler
We're gonna
dev, you
make
start
it
with
standard.
LCC.
Ridiculously
The standard
the use case.
XKCD, yes.
Yeah, if we're not making a new standard for like, we're not competing with not proprietary, but like big compilers.
No, we're going for the hobby grade.
Exactly.
Like if you just want to make a language and you think that's cool, come over here, we'll help you.
Yeah. We're like half a standard.
We don't have standards, we have half a standard.
This was,
go.
I mean, the original goal is to do this for fun, so whatever.
Exactly. And I think that's kind of the point I've realized and why I'm very loose on this now, is like I think I feel like we did it. A lot of people put a lot of hard work in, and this compiler's awesome. I'm proud of it. We did it from scratch and for fun, and now we're going to do it again.
Yeah. So, should we get started on just planning out some simple things right now, or?
We can. Maybe let's talk about... We could talk about the AST.
Yeah, I would start with that.
So we're going to go with inheritance. What does that mean?
What that means is I can like dictate some code to you, or I can share my screen and show my implementation of that. Whatever you prefer.
Let's go for your screen.
Sure.
Please don't share bad things.
I shan't. Okay, hold on. I need to... Is this the right... Yes, it is. Okay.
Roshanus is...
C-line. Where's C-line? I think it's this. It looks like it's... Hold on. I'm gonna...
Old C++ wouldn't be an upgrade. Yeah, we're gonna start with concept, so...
We're gonna start with C++ 23, yes.
Yeah, and it's... We still are gonna figure out... We're gonna try and have it easily... like a tutorial, basically for me, so that we can get it working in WSL.
This should be my C-line window that I can see here, right?
Here. I'm scared to look.
Yeah, it looks fine.
Yeah, that's good.
Finally, 60 FPS.
Okay.
You can always watch a Twitch stream too. It's a little behind.
So I'll show the case list with the AST of my compiler real quick, because that uses like this is very similar to Klang's AST. This is a bit different from the AST we're gonna write for Intercept, because in my language types are expressions, so everything's an expression, including types, which makes it more complicated. But the basic idea is we have an expression class, which we should call exp and not expression, because we'll have to type that everywhere. So let's keep names short, please. And what this basic...
Uh-oh.
Wait, what?
Goodbye.
He's gone! No!
Discord just restarted for some idiotic reason. So
He's
hold on,
back.
Let's try this again.
Fantastic. I'm glad that was fast.
Damnable program. So, what part of that did you even hear?
Not
of it,
typing
basically.
the full
You
expression.
were only gone for like 2 seconds.
Right. So, this is the base class for expressions. We should call it exp, not expression, because that's too long. So, I'm going to mute the other server real quick. There we go. So, this basically just has things that are common to every expression, like a location. This is just marked mutable in case we want to modify when it's const. That's not really important. Probably a flag whether it's been type checked. That might be useful because some things depend on that. Probably a virtual destructor. We might be able to do without that. But just in case, we should just leave it in here for now, I'd say. Is it clear why we might need that? Can you still
no.
hear me?
Yeah,
I'm
that's a
also
question.
just asking questions to make sure you can still hear me, because I can't tell when you can't hear me anymore, because you'll just be gone. So
That's fair. That's
so
a good...
Okay.
That's a good idea. He's gone again.
He's gone.
It's got it.
Yeah. Okay, Lens, could you maybe stop sharing your screen? Maybe that might help.
Yeah.
My bandwidth sucks. There's too much going through everything. I'm also
Maybe if
gonna
you weren't running
close
60
your
FPS.
stream.
I don't know how to do this.
Stream at 5 FPS.
Just close your
Oh,
stop.
please
Just click
no.
the stop game button.
I can't click the wrong See? I'm scared.
Jesus Christ.
Guys, I missed something.
I will say my network sucks. That's the reason why this is not going well.
You should.
30
who
or
is
15
it?
instead of 60 FPS.
What's the company
I
name?
don't know where to do that. Hold on.
I ended
Let's
again.
see.
Who's your ISP? Shout them out.
I'm also mad at them. They suck.
What's their name?
Okay.
I hate Comcast and Xfinity. They suck.
There you go.
Same.
But
That's slightly better, yes.
I can. Oh.
And he's gone.
Apparently it doesn't. What the fuck is going on here?
Maybe we just dictate to Lens then.
We'll
I'll do
try
my
this
best.
again, and if it still doesn't work, then we'll do that. Jesus.
Doing it live.
God. Stupid program. I have a window open that just pings Google to see if it's my network. I can also try Discord in the browser. That might also work better than this. We'll see.
Oh no.
I'm pinging Google on my other window to see if it's my network or if it's Discord. So, basically what I was talking about, the virtual destructor is so we can, if we have some kind of expression, obviously we won't have, just ignore the squiggles, that's because it doesn't have semantic analysis in here. Or I guess I could put that in here real quick if we have some. It's slow because it's a large file, that's the only problem here, so we'll not do it in here. It's very slow because the file is so horribly big. So anyway, if we have some sort of expression, if only I could type, we can do delete foo. And this only works properly if the destructor is virtual, because if this is actually some subclass of expression, and we just call delete foo without a virtual destructor, it will call the destructor of the base class and not the destructor of the derived class. So for it to call the destructor of the derived class when we do this, it has to be a virtual destructor. So that's why typically if you have inheritance and you want to be able to just pass.
Okay.
Virtual destructor. I'm going to move Discord in the browser 1 second because this stupid thing clearly isn't working.
Clearly. God. So basically, what you're saying is we're going to end up with an expression, which is similar to what we have now. Here, let me turn off.
1 second.
We're going to end up with an expression. It's basically a struct. It's a C++ struct, so call it what you want. But what you're saying is, we're going to store things through inheritance. And then, so what kind of cast are we going to use?
Hello? Can you hear me?
I can hear you now.
Hello.
Okay, I've switched to the browser. Let's see if this works better.
What kind of cast would we use?
Oh god, now I gotta find the thing in
here.
Stop panicking before you windows open.
Yeah.
That's a tab. I need to look like Windows.
I can't believe you didn't practice this, Eternal.
Oh, I've never had this problem before, so I have no idea what you're talking about. Oh, Jesus Christ, Discord. Okay, so I just explained why we need virtual destructors. We don't really need them, but we might want to have them. So this is a thing that I've done here. We can do the same thing. Is we delete the normal operator new. This means you can't just call operator new on it. You can't just write this. Because ideally we don't want to have, so you can't just call this, because ideally we don't want to just have to keep track of everything everywhere. Ideally we just throw all of the expressions into some context, and when we're done with compiling we deallocate them all at once. So we don't have to keep track of when to free expressions. But in order to do that, it's best to make sure that we can't just make a new expression that's then just dangling. But what I've done here instead is I've deleted the normal operator new, meaning you can't call that, and I've provided a second one that takes a module as a parameter, so that way you have to write something like this, and that will then call this, which can then add the expression pointer to the module. Basically, we can run custom code when we allocate this thing.
Yeah, so you're using function operator overloading to overload operator new for the expression structor class, and you're overloading it in such a way where you delete the normal one where you just say new expression, and you're saying that we have to explicitly pass in the module the expression comes from. That way, every expression, aka AST node, right? Intercept AST node, is going to end up as relating to a source module and know where it came from and the file and
source
etc.
module is called because the language is called source, but yes.
I see.
And in code, this looks like this. We make a new integer literal expression with an integer type, and the type is int.
Which is very similar to how we do it now.
Yeah, sort of.
It's just using C++ constructors instead of explicit functions.
Yeah.
Which is arguably nicer.
The alternative way is if you this is the one way of doing it. You have a protected constructor. Oh, sorry, no, you have a public constructor that everyone can call. The alternative, instead of doing this, is we can make the constructor protected and just have some create function that allocates and returns the thing. That's the alternative. That's the factory pattern, they call that sometimes. You'd probably also have to make this a template. We might want to create an integer expression, so it would then allocate and return one of that. That is the other alternative, to have some create function somewhere. But I feel like this might be easy to write. But it's more or less equivalent. If you write new mod integer literal expression or mod.create in template brackets into the literal expression, then the parameters, it's the same thing really. So it's the difference between like this and basically this. It's the same thing.
Beautiful.
I prefer the new syntax myself.
Yeah. I feel like this is a bit easier to write.
Yeah.
Yeah, so this is how you'd implement that. And then there's some common functions in here, like getting the location. For the location, you could just make this public because it doesn't really have invariants. But because of having to do so many refactors, I'm just wary of making anything public in the AST. But we can make, for instance, the location just a public member.
Wouldn't hate that.
Yeah,
obviously, you shouldn't ever be copying or moving AST nodes. At least not in this manner. So we delete all of these.
Yeah, I would hope we're not doing any of that. By the way, so we're going to have expression, and then we're going to have derived classes.
Yes, we can go, for instance, to, let's not go to the
like
root.
Integer expression.
We can have a for expression, for instance, that has a body condition, increment variable, blah, blah, blah. A constructor that calls this I'm going to explain this in a second, but it just basically initializes all of this. Then we have some accesses. Note currently there are no accesses to set, for instance, set the condition. What I do is just have getters at first and then just add the setters if we really need them, but prefer not adding them because we shouldn't just be mutating too much the AST around too much unless we really have to. If for some reason we actually have to set the condition somewhere, then sure.
What kind of cast are we going to use to get from an expression to a for expression and vice versa?
There we go. That's the next thing to talk about. So there's a few options there. There's two main options. Both rely on runtime type information because basically, in order to be able to cast to a for expression, we need to be able to check, is this a for expression? Right?
Yep.
So there's two options for that. We could use C++'s RTTI because this class is polymorphic. Class is polymorphic if it has at least one virtual function, which we do, which means that every instance of this class has a pointer implicitly that points to its vtable. And since the vtable pointer is unique for each class, we can look at the vtable pointer, check if it's the same as the one for expression, and if so, we return a pointer to it. There's an operator that does that in C++. It's called dynamic cast. Dynamic cast for expression of some pointer of some foo that is an expression pointer will return null pointer if it's not a for expression pointer or any derived class, and it will return a pointer to whatever the for expression is of this. So that would be one option to use dynamic cast. There's only one problem. Dynamic cast is horribly slow. And we might eventually get rid of this virtual destructor because it's not perfectly ideal either. So this is a bit of a scuffed way of doing it because virtual functions and all that. So the alternative is to just hand roll our own RTTI, which is the same thing what LVM does, basically. It's basically combining the inheritance approach with the union approach, where every expression has a kind. That is then, well, in this case, even const, because there's no point in reassigning it, because we don't ever overwrite that. And then for instance, a for expression has to pass in implicitly, the constructor does that automatically, that this is a for expression. It passes that to the constructor of expression. The constructor of expression stores that in this kind. And then it's as simple as checking, is the kind of this expression kind for expression? And if it is, we cast it to a for expression. Now, we don't want to have to check that manually. I'm actually just reusing LVM's RTTI for this. And the way they do is they have a set of operators where you can write if something is a for expression.
Right.
Then you do something. There's a few operators. There's also cast. There's also cast, which returns a pointer to that, and it asserts that it is this. And then there's dyn cast, which returns null point if it isn't. I'd not call them is, cast, and dyn cast. I typically call these operations is, as, and cast. We can call them something else. We could make them free functions. We can make them member functions. But that's how I'd access them. Like, just write something like if... then here you can use F to access the for expression.
And cast would return...
You can declare a variable in the condition of an if.
So cast would return null.
Pointer if it's invalid, so this if is only entered if this is not null.
And then if it isn't, you also have a reference to it and can alter it and do what you need to.
Exactly. So that's... And if you want to assert that it is a for expression, you can cast this. I would write, I like using as for that. So you could write it like this, or even in here, it doesn't matter. But you wouldn't need an if in that case, so that would be like an asserting cast. If we know it's a for expression, we want to make sure it is. And if we just want to check, we can use is for that. That's the names that I like to give these.
And that returns a bool?
Yep.
I would return a bool, yes. We could just reuse cast for this, but is 2 letters shorter. So, but we could just
and it's more explicit.
Yeah, and it's not clear what cast means.
Yeah.
Okay.
I like those.
And the implementation of this would also, what we can also allow for is in particular is we can check multiple things, like is a for expression or an if expression. And how this is implemented, that is what we're going to talk about later when we talk about fold expression.
Yeah, that's going to get with your folds, yeah.
Yes, we're going to talk about that later.
I don't want to get in between your folds.
So we're going to explain how we implement this later. But it's essentially an easy way to check, is this any of these? And that's an operation that's just very common.
Can you imagine doing that in C?
Yeah, exactly.
I can't. It would be some horrible Vararg like macro stuff.
Yeah. Before C++11, this would have been... I can't think of a way of writing this before C++11 that would have been any decent. So we'll go over that later, so let's not talk about that anymore. But yeah, that's how this sort of RTTI would work. And we'd either implement as is or cast free. But the way LVM does it, it just has a single
free function. I think that's the way to go.
That in a class that has a few subclasses. For instance, I'm not saying need to copy the layout that I have exactly. This is just what I've done, and this is what I'm using to illustrate my point here. If we end up, for instance, with I have typed expressions, because some expressions may not have a type in my... We can also have everything have a type, and this is just because I don't want to store the type in like a for expression or something. There still is a type function that will just return void or something. You could do it that way. But this basically has a ton of subclasses. And the way that LLVM implements RTTI is that there is a single function called ClassOf, which is passed in the base class, and it should return true if and only if this thing is a subclass of this. So for instance, the class of expression for typed expression returns true if and only if this thing can be cast to a typed expression or any of its subtypes. So you basically just have to slap this implementation in every AST node just has this function. Most of them just check, is it the same as my kind?
So we're basically explicitly saying what a valid conversion is.
Basically, yes, we're encoding the valid conversions in here. And the way this works is if you look at this enum, it's carefully designed to where, for instance, all the typed expressions are grouped together. So you can just do a great.
There's plenty of ways to do it, yeah.
The exact implementation of that is not that important. It's just, and also how you get from ClassOf to is as cast, I can just take care of that. But the main thing for the AST would be that every AST node has this thing in it. We don't have to call it ClassOf. We can call it something else. That doesn't matter. LLVM calls it ClassOf.
Yeah,
this would basically be our own version of RTTI, which is typically what people do, because the sad truth is that C++ RTTI is just very expensive, both to use, and it also has a giant binary overhead to the point where typically projects just disable RTTI.
I do.
LLVM, for instance, does that. And I can't even link against LLVM if I have RTTI enabled. So I have to disable it anyway. We don't have to disable it, but I'd suggest...
I think we should, yeah.
Yeah, the only thing that this disables is dynamic cast.
We should never
need. Uses RTTI and also the type ID operator. Those are rarely ever really used.
Yeah, we should never need type ID.
Yeah.
I'm just going to shout out Morushana, Athano, and Nacrimes. Thank you so much for the follows. This is so awesome.
There's problems with these operators because the implementation of dynamic cast is very generic, so it's very expensive. And type ID can be at compile time or at runtime, depending on whether its argument is polymorphic, which means it has confusing semantics. So I wouldn't ever really use these two.
This is kind of adjacent, but why is dynamic cast expensive? Isn't it compile time?
No, it's not, because what dynamic cast does is you're just thinking of the simple cases. Which is casting from, for instance, a base to a derived or a derived to a base class. But there's also things such as cross casts. If you have multiple base class classes and you want to cast from one base to another.
Ah, I see. And then
that's a cross cast. That's expensive. And because dynamic cast can't possibly know which one you're dealing with, because it's dynamic typing, you can extend the types at runtime even, potentially, by loading just a new DLL or something like that. It has to go look into the vtable, see which case it is, and then do that, which is expensive by default. Of course, if the compiler knows that you're just downcasting, it just does the same thing. It does devirtualization, basically. It converts it to a static cast. Sure. But the problem is that in the general case, it doesn't know that, so it just has to call an expensive implementation of that.
So if we put final...
This is literally just a single comparison.
If we put final on some of these, would it do... That's compile time.
That doesn't really help, simply because a lot of these are not going to be final also.
Ah, naturally. Okay, good to know.
Yeah, final helps with that a bit, but it's not ideal.
Yeah.
It's as I like to say, it only serves to reduce the problem to a more manageable level. It doesn't get rid of it.
It's by no means a solution, and if we can avoid the problem altogether, we should.
Yes. And the problem being RTTI and also virtual functions. That's the other thing that's slow.
Okay, I'm all for FNO RTTI. I don't like inheritance, but I don't think this is necessarily inheritance.
Inheritance is basically, I mean, it's not OOP style inheritance where you have like OOP style of doing it would be like something like every class defines a codegen function that then codegens this node.
Yeah, the Kaleidoscope tutorial. Yeah.
That's not particularly something I like. What I just do is I just have one single cogent function that then does an if-else through everything. That's very much not the OOP way of doing it, but that is typically easier to deal with. That's what I would do.
It's fantastic.
Yeah. Yeah, you
Yeah.
can switch on the kind as well instead of if-elsing everything.
Yeah, sure. You can switch. You can switch on the kind as well. Sure. Or you can use the for many cases you can just use this is and pass in like the 5 types you care about or whatever.
Why not
Yeah.
use virtual
So-
function? Is
Slow.
it
Well, we
for
don't want to.
performance reasons?
There's 2 main problems with virtual functions. One is they're slow because a virtual function is 2
Okay.
pointer loads. You have to load the vtable pointer that's stored in the object, and then you have to load the function pointer that's stored in the vtable, and then you have to do an indirect branch to that function.
Cache
Okay, so
That's
locality.
performance
like
reasons.
3 things that are
Yeah.
horrible. Like the loading the object, that's basically free, because if you're calling a member function, you'll have to operate on it anyway. Otherwise, like, there's no point just passing an object around if you're not using it. So you're loading this pointer, that's like negligible. But like loading the vtable and then doing an indirect jump, that's not exactly ideal, and that can slow you down. So that is one problem. The other thing is it just distributes the code all over. Like if you have a
I
a
see.
codegen function that's split across 30 AST nodes, that's a bit confusing to find where everything is, even if everything is just implemented underneath each other. So I would just put it in one place.
I see.
And also,
Yeah,
2
that's
AST
fair.
nodes might be codegen similarly, even though they're different or whatever. So, like trying to split functionality across virtual functions, the one argument that I typically get from OOP people is, I can easily just add a new class and extend everything just by modifying my new class without having to modify any of the base classes.
Add a new
That is
branch.
true, and that may make sense for some things if you're consuming something as a library. So virtual functions may make sense in like at the API level. I still wouldn't use them for APIs to the compiler, to the intercept library. But if you want to use virtual functions in an API, I can see why that would make sense, because that's really meant to be extensible at runtime. The AST is very much not an API, so I wouldn't really consider for there to be any need to make that extensible.
Yeah, anything that's in the front end,
in the function.
anything that's in the front end is never going to be extended at runtime, because it's just going to be extending the compiler basically. So we want it to be super fast and static.
Yeah, so virtual functions already have one use case for virtual functions definitely makes sense is what we have in LensorOS drivers. Just make the driver interface a virtual function, because you know what the Linux kernel does? It passes around a struct of function pointers, which is basically just a virtual function but scuffed. So yeah, at that point it makes sense, because that really, if you're just loading in kernel modules at runtime, you kind of need some kind of dynamic API. So that makes sense, but it doesn't really make much sense for a compiler, I would say, or at least not the kind of compiler we're writing. For these kinds of systems, there's just no good reason to use virtual functions, especially considering all the problems they bring.
Yeah, if we were to use virtual functions anywhere, it would be in the middle, and that's almost purely data transformations and still doesn't need it anyway.
Yeah. Like the only thing where it makes sense to make it virtual just as a safeguard is the destructor. Otherwise, we'd have to downcast before deleting. But we could, and the thing is, you would never, we would have to make this destructor protected, basically, or something like that. Like there's some, or private even, because you shouldn't ever be called, because you can't just call a derived constructor if you're already in the base class constructor. That's not how that works. That's not going to end well if you do that. So you'd have to make it so no one can ever call this destructor, and just have another delete function that then does the downcast and calls the appropriate destructor, which is a bit annoying to implement. We can add that later at any point, but for now, I'll just make this virtual and be done with it. That's not really a design thing, because that's just changing one, because we're only going to be calling this in one place, really. That's when we free the entire AST when we're done with it. So refactoring that part will be trivial, basically. So we don't really have to worry about how we implement that, because we're not going to be starting to delete AST nodes all over the place.
I see. Well, you can make the same argument about having the destructor in multiple classes. You can just implement one huge switch statement inside the expr class and be done with it. No?
That's what we might just essentially, yeah. But for now, I just want to be done with this part, because there's so much other stuff to do. We can go back to this later. It's just not important.
We can add it to
That's fair.
What's the? Is there anything else? For instance, one thing that can be where's like a, and the same thing, but we basically have this compiler only has one hierarchy because types are expressions. But we'd have 2 hierarchies. We'd have expression, and the other base class would be type. Then we have these two big hierarchies, and type would be not even just the types for intercept, but that should probably be the types for of the IR of the entire compiler system. And the intercept AST just uses those. And the lie AST can as well if you want local, or you can.
The lie one
create
is
your own
probably
type
going to have
system.
a 2-pass for a syntactic type and then a
Sure.
semantic type because it's going to be more ambiguous. But yeah.
Something I want to look at. Oh, for instance, one thing that I've liked, there's some just common things that you can abstract out, like where's just decal. For instance, in declarations, where's declarations? Hold on. I have object declarations because there's some things that have a name, and things that have a name typically also have linkage and linkage, and
Yeah.
they also have a mangling scheme. So, for instance, this is for currently just functions and variable declarations. If we ever add things like if you add like values or something, then that would be a sub as well. So this is already all the mangling functionality can just be in here, and like
Yeah.
a function doesn't have to care about how it's mangled. That's just handled in here. Like there's stuff like that that you'll notice when you're writing the implementing all the AST nodes, or I can do that or whatever when we just to that, and just whenever you see stuff like that, just abstract it out a bit. And that way, yeah, you might get a hierarchy that's 5 levels deep, but it's just like it's not multiple inheritance, it's just single inheritance. That's typically fine.
Not
Also,
important
multiple
question,
inheritance will mess with this, so don't use multiple inheritance here.
Yeah, don't do that. Not important question, but just I've always called them entities. Anybody care about entity versus object here?
I prefer object.
I don't
Yeah.
particularly care. I just called it
Cool.
object decal because I couldn't think of a better name.
I'll go with either. I'm just used to
Decal
entity.
with linkage that's the semantics. It's a declaration that has linkage. If you can
Yeah.
find a better name for that than object decal, feel free to rename it. Like renaming a class, I can just press Shift F6 and rename it. Like the naming
Yep.
of the classes is not really that important.
Yeah,
It's more
I've
about
just always
the
referred to my top level things as entities. So wondering
Sure,
if
you can
no,
call
we're
them
good.
entities if you want.
We're gonna call
That's
them atoms.
relatively
Whatever
irrelevant.
Lens wants. If the Lens is compiled.
Yeah.
Because I'll do whatever I want in my Laie front end. Whatever you guys do in the intercept front end is all you.
Decal.
Is there something else that's interesting to point out, or is that pretty much everything here? Because this is just the same thing over and over again across nodes. It can end up like it can be a bit boilerplatey for stuff like, let's see.
But you're
like
only
a
writing
two-
it once and never changing it.
Like the minimum
little
that everything has
babies.
to have is a constructor that just forwards stuff to the parent, as well as the RTTI thing. That's the minimum that every class has to have. And I typically don't like writing class and public right at the top, but I've just decided to make everything a class simply because there are ABIs that distinguish between class and struct. In case you don't know this, in C++, the only difference between class and struct is a struct is default public, a class is default private. That's the only difference. There is no other difference. Keep in mind when you inherit them, there is such a thing as public and private inheritance. So if you're using class, inherit publicly. Otherwise, this is not going to, and none of the inherited members are going to be visible, which is not the point of any of this. So we could also use struct everywhere. I've just used class here because because the way I organize classes, I put members at the very top, typically, which is why class makes sense for me because those are private. That's the only reason why I'm using class and not struct here. That, and because I have forward declarations, so for forward declarations, I already have to know whether it's class or struct, because it has to be the same as the definition, otherwise some ABIs don't like that. Particularly, and by some ABIs, I mean the Microsoft ABI. System 5 doesn't care.
Just as a side note, Suraid really doesn't like to type, so the fact that he has to type the extra public every time, and he actually does that instead of getting rid of it and just using struct, shows you that how important it is.
Mm-hmm. Also, I didn't type most of this. Copilot just auto-completes it, so...
So you said something about types being expressions. Can you just pass them around? Are they like
it's
first
just
class?
In my language. It's just in my language.
We
you
are
can
gonna
write
have that.
whatever.
Is it a compile time thing? Or
No, not
mainly,
necessarily.
yeah. But not necessarily. We could make them compile time, but yeah, something like a return t size. Then you would be able to call it like this. That should return 8. Basically, a type can just be used as an expression. my language. That's why everything is an expression, even types.
You
Which
return,
makes
for
a few
example,
things annoying.
you return, for example, a vector of t, of type t, inside the function, inside
You
the procedure?
can return a type here, yeah, sure.
Okay.
But that's typically only going to be useful as a template, so you'd then make this a template probably.
Ooh, interesting. Okay, thanks.
And that doesn't even use macros.
It's just a peculiarity of my language.
Yeah, I want to get Laia to also support.
Intercept, expert, and type would be the two top-level classes with no common ancestor.
For now.
Whereas here, type just inherits from expression. Oh, and yeah, one more thing. These should probably not be globals, at least not the FFI types. Once we add, we don't have CFFI, but once we add that, that should not. Those should. We sort of do have them, but those should not be globals because they very much the size of them depends on the ABI. So the size should not be stored in here. So what you do is I would do the same thing that Clang does, where Clang calls it an AST context. We can just put that in our top level context, and then you'd like call context type size of some type. So that would be for all types that we don't know the size of for sure.
Yeah, that makes sense.
Alternatively, the type you have to call size. You can call size, but you have to pass in the context. Either way works.
GMOSX says proc. No, this isn't. This is source.
This is my language. Yes, let's go over here.
And proc is fine.
What was I? Yeah, for instance, this is a very abstract thing. The single element type base would just exist because pointer types, reference types, slice types, inclusive range types, exclusive range types, closure types, decal type decay types, type of types, and array types. Now, array types are different, but all of these are just types that have a single element type.
Yep.
That's it. So I've abstracted that out here because I don't want to type that and that every goddamn time. This is like an example of what I meant by just factoring things out. And two things to note for this RTTIs. Again, if you have questions like that about this, just let me know. This can be confusing if you're not familiar with it. But basically, there's two things you have to keep in mind. If this thing is never meant to be instantiated, because it doesn't really mean anything on its own. Only it's the same thing with how expression isn't meant to be instantiated. Only it's derived classes. So if that happens, make the constructor protected. That way you can't ever create one of these.
Why not private? Is it like I see you using
private means that derived classes can't access that. That means you can't derive from it really, because derived classes like pointer type still has to call its parent constructor.
Oh, okay, I see.
Yeah. So you have to make it. That's like the protected doesn't have many uses, but this is one of them. I
didn't think it was used.
And also note that there is no class of for this currently. You can't, or if there is because this thing doesn't. There is no kind that corresponds to this because you should never instantiate one of them.
Right.
Also, the fact that there is no class of is actually weird. There should be one that just checks if it's any of these derived types. This thing itself doesn't have any place in this hierarchy, basically. It just serves as the parent of all of these.
All right, so what we've discovered is that the way that we have everything split up into different values within the node union, the node value union within the node struct, that's basically going to become, each of those becomes its own type.
More or less, yes.
Instead of becoming one big union type where they're all sharing memory and stuff.
So the nice thing about that is, for instance, that's something like I'll just mention real quick. So, for instance, something like pass if expression.
Yeah.
And just return an if expression now. So we know if we call pass if expression, we don't have to cast it to an if expression afterward. We know that it is one.
Hello, Barak.
That's something you don't have with the variant approach. You can't just tell it, hey, this is actually this variant. In the type system, there's no way of doing that. With inheritance, there is.
Yeah, that's something to mention is that very quickly, we're just going to go over this. Variants are not mature enough to be usable.
There is one place where I'm using them, and that is in here, up here.
That's okay. We don't need to look at it because variants are bad.
Because that just has a variant of
We don't need to
stuff
look
that is
at it.
just data, and then you can just grab
No
it.
variants.
Yeah,
That is the
we don't need to look
use
at it.
case for that. You just need a bunch of data. That's it, and you these don't really have fields that just passed around.
We
This
don't
is
need to
a
look at it.
constant expression result that's just passed around, and you
Bruh.
didn't really do anything with this. So
Yeah, that's that.
like,
We
this
gotta
is a
move
use
on,
case for
otherwise we're
Silent
never gonna
Variant.
get to it.
If the semantics is really just you have this or this, and that's all there is to
We
it.
don't need to talk about variants. We can move on,
Yeah.
please.
Sure.
Otherwise, we'll
Lorenzo,
never
you're saying
get to
stop
it.
talking about variants. Eternal over here continuing to talk about variants.
I know. I'm like, don't talk about variants, please. Just mention this quickly.
Interesting.
You went on in 5 sentences.
Because I think this is mostly it, actually.
It is. We're moving on.
I think that covers it for the AST.
You can do stuff like this now. If a var declaration
don't-
has
it's
in
fine.
MyAST, it has a function that owns it, and this can now actually be a
Everyone's
function
eyes
decal
have
and not
glazed
just an
over.
expert or some random tree thing. You can actually just store pointers to subclasses, and everything should be just passed around as a pointer. We would think that you could make it.
Okay, we gotta, bruh.
Not really, because you have multiple references to things. A shared pointer is not a good idea because a shared pointer is very expensive, and other reference counting is just not really necessary, because what you'd have to write then is you couldn't pass around pointers. You'd have to write you have to pass around something like, I'm not going to type in here because that's going to take 5 hours. C-line is a bit slow, unfortunately, with stuff like that. But what you'd then have to pass around, instead of this, you'd have to pass around something like a ref of function decal everywhere. That is something you could do. It's not really necessary.
Oh, that's better.
I would suggest throw everything in the context and delete it all at once when you're done.
Yep.
Clang is even more cursed. What Clang does is
I don't think it's gonna stop.
it just has a bump allocator, and it doesn't even call the structure. It just frees the entire arena. Like in Clang,
Yep.
it asserts that no class has a destructor.
What's your favorite type of coffee?
And then just deletes the entire thing at once, which requires a bit more work in implementing it. So that's why I wouldn't do it immediately. Just do it the simple way.
So good.
Clang memory management, which is very efficient, but also maybe a bit.
It's not low enough.
What's next?
I think we're mostly done with this, right?
Please
Yep,
talk
what's
about
next?
yes, we're done with this. We've been done with this. Can we start talking about C++ and some stuff about that?
Just one last thing I'd like to
No,
Oh,
there's
no.
not.
We'll actually do the same thing for the IR. So the IR is also going to be
Ah,
function block expression. But the block doesn't inherit from a function, so it's not even that. It's just functions, blocks, and instructions. There's one thing I would suggest, though. We don't have to do that.
we can do a
The way
we need hot dogs.
LVM does it is if we can we look at anything.
Who's got the buns?
Nice. Hold on. Do I have an LVM header somewhere? We could try and go maybe. Oh, this might be a bit. We'll go here and we'll go to. Can I find that real quick or not? Probably not. So I'll just type it out. Basically, the way it works is that in LVM everything is that the root.
It's an interesting one. He got on a topic, and I don't think he can stop. He is on it. Is he still? Is this still AST stuff? I think it's still AST stuff, guys. I feel bad muting like this, but it's fine. I'll come back.
That way you can just create a block and pass that to.
Yeah, he's still going. He's like a machine, man, like an engine. It's amazing to see. It's like I started a 2-stroke and there's just infinite gas, I guess. maybe it will run out of gas one day. It is just an engine. All right.
Lens, did you catch what I just said? Or
Yeah. It was
I
caught it in passing.
That's what I would suggest. Just having some value-based class and have instruction, block, and function, and anything else that we might.
What's
have
next?
Yeah, so let's talk about C++ and like that. Remember what we talked about yesterday? The references.
Yes, we can talk about reference. Do you want to talk about fold expressions first or references? Because fold expressions is faster to explain.
Let's do fold expressions if it's faster.
Okay, I'm gonna switch
hour
over
later.
to Compile Explorer then.
Oh no.
Disconnect instead
Oh,
of stop
I'm so
streaming.
happy. That
Good
was
job.
a
I was
great.
gonna click stop streaming because I have to switch
We
to.
had 2 seconds of silence. Let's go.
We're gonna switch to.
Let's go.
We're gonna switch to Compile Explorer.
Local. I can't wait.
Hello.
I can't wait to show you something later.
Can you see my browser
boy.
window?
Yes.
What's in it?
Very, very quick. Okay, never mind.
That's wide.
It's
No,
a
go ahead,
local
Milady.
instance of Compile Explorer, so it's a bit faster.
It's
I'm
not
going to
important.
grab all of
Okay.
this, and I'm going to move that into intermediate document. That's the references stuff. Don't worry about that. We're going to remove this, and we're going to for references, I'm just going to copy this in. But for this, I'm also just going to type it in because that is faster. So we'll see. We have the code on the left and just the compiler output on the right. With warnings turned on and standard is C++23. So basically,
So wide.
the way I'm illustrating this is we have a variant, because that's the easiest thing I could think of, and we want to implement some kind of is function. Exactly that. We want to check if the variant holds any of these. And the way you'd have to do
hold
this
on.
in C++ normally is you'd have to write standard holds alternative.
I'm gonna start doing this.
Int or standard.
So basically what he's talking about is there's C++, right? And in it, there's a thing called variants. A variant can hold like a value of different types, much like a union in C, right? A variant, it's actually kind of cool. I have like an engine I got to keep up with. A variant can hold each of these types, and you have to check using this horrible way whether a variant contains the type that it does, and then you have to access it in a very certain way, right?
What you can do get if, which returns a pointer, or just call get, which gets the value. And so the get if is sort of cast, holds alternative is, and get is like the as thing that I mentioned earlier. So obviously no one ever wants to write this. So the first improvement would be, we don't want to have to write standard holds alternative, and this isn't going to take too long, by the way. Let's just write is for that. That's the first improvement. So we have to define a template that does this. It's easy, we just find, and you can do this in even C++98, I think.
Yeah, I think this
So we
is
just define a template.
this is a refactor I would do. While you're typing, I'll describe this, where it's like if I see a lot of long code where it's like this one really long function name that I use all the time and I keep using it, I'm going to rename it to something shorter most likely, or a little less horrible to type. That way I can just actually function and actually read the code. Because it's like if you see if standard holds, your brain like just misses the whole point of the code. But if you see if is int, is short, is unsigned, then you can start to read it and like quickly parse what's going on in your own code. Reading other people's code, it still gets confusing what's going on, obviously.
This is
Wait,
I don't think I. Yes.
Can't you like have multiple template arguments for example, say is int, comma, short, comma,
We're
unsigned?
getting to that. I'm explaining how we get there.
Ooh.
Just listen.
Okay.
You're too
Oh,
smart, Miludi. You're too smart for him.
Yes, I'm trying
I'm
to
sorry.
explain what
I'm
if I
sorry.
just throw in a fold expression, then people
Okay.
start complaining that they don't understand what's going on. So I'm trying to go slow.
Okay,
I don't think I have to explain this one.
we have to go a little.
Variant parameter is just deduced from the argument.
We've got a
here.
question.
This one is passed in explicitly. Yes.
What the fuck is auto pointer equals standard get if int reference foo I equals star pointer?
I can okay, so this one, the way you have to, so the thing is, if you just, in here we're storing an int in the variant, so the type of this is int. So what we can do to extract this is we can write like int j is standard get. This is how you'd normally do that. Int, and that gets this foo out of here. And we can see this works. If I try to put a short in here, it will terminate with an exception because it doesn't hold a short.
That's
So
also
standard
known as
get
crash.
asserts- Yeah, sorry?
That's also known as the program crashes.
Yes, the program crashes. Because what happens is get asserts that this contains a short. It doesn't. It contains an int because we put an int here. So it just throws an exception.
Which is much like what we do in C. Like we throw in asserts to our functions that just crash the program if it's not expected.
So what you have to do is this annoying thing where you have to do if standard holds alt. So you can see how long this is. Alternative of int. Sorry, in this case of short maybe. And then actually let's put int in here. Hold on. Let's use int for this.
You have to pass in foo.
You can call standard get of int on j, and I need to actually pass in the variant here. And as you can see, it works if it holds an int, but if I put a float in here, the program doesn't crash. This code simply does not run because the if returns false. So that is the primitive way of doing it because this is so annoying to type. They added a function that combines the two, which is standard getIf, which was both at once. It returns. What it does is it takes in, for some reason, a pointer to the variant and returns a pointer that is null if it doesn't hold an int, and a pointer to the int if it holds an int. That's what this line down here does. It's just I was going to explain that and I forgot about explaining this, so that's why this was still in there.
And then notably,
that is how the standard library. Sorry, that's how the standard library wants you to use variants. Go ahead.
Just to clarify and preempt any other questions, that if condition is going to evaluate to the value of the pointer that we declare, which is why we can put it in the if.
In C++, if you declare a variable inside, you can declare a variable inside an if, and it has basically the same effect as doing this. The pointer is the condition. Variable is the condition that point, and because it's a pointer that works. That's what this is for. Back to this.
One more question from Barak. What does the memory storage look like for a variant? Is it similar to an array? And then
it is a union. It's a union under the hood.
Yeah.
It's just type-safe bracket. And under the hood, I mean, it's like 20 templates deep.
And can you explain just very quickly in one sentence why unions aren't usable in C++? Maybe 3 sentences.
Unions aren't usable because unions are unsafe. The problem, you can't do type pointing with unions. That's UB. You can do it in C, not in C++. And the problem is also if you define a union, then a union by default has no copy constructor and no destructor because you'll have to implement those manually because it doesn't know what it holds, so it can't provide a default implementation. So unions are just very annoying to use.
So
unsafe as well.
C++'s type system is so strong that the type unsafety of unions, which is usually their strength, becomes unusable because the compiler's type checking doesn't allow that. So then it's like, why ever use a union? It's not ever useful. And that's where standard variant is trying to fill. And it does in some cases, but not for most cases where people actually try to use it.
The question of using standard variant versus using a union is the same as using a standard vector versus writing your own. If you write a variant or an optional, maybe not an optional, but a result type or something like that, you can use a union internally, but just never expose it. But using unions directly is the problem. That's horrible, typically. Yeah. Not just horrible practice, but also horrible to use.
GMOSX says we need IQ tests.
I just want to say it's either this, or this, and that's all I want.
Yep. What's your IQ? GMOSXX says we need to do an IQ test for you.
I have no idea.
I need to do one as well.
But yeah, so this is fine, but it's still a bit verbose. It would be much nicer if we could just write this, right? Short, unsigned, long, and long. And
basically,
then we can delete. And also, there's a problem with this, is we have to pass in foo 5 times. So if this is a temporary, we have to make it a variable for that. And that's just annoying, because we don't want to evaluate it 5 times. So instead with variables, just like to write this. How can we write this? Well, before C++ 98 could go, before C++ 11, the answer is, the way you write this is you write it the stupid way. You write this. Pass in 5 types. You check if it's either of those. So you just literally copy this code from down here and put it up here.
Fantastic.
That is how you do it before. So this is pre C++ 11. That's the only way of doing it. I don't think I have to explain what the problem with this is, but just in case anyone likes this code, if you now pass in, so here I can just call is5, that will work. What if I just want to pass in 4 types? This takes 5. That doesn't work. I have to create is4 that does 4 checks. And I have to create a separate function for each combination, each number of types.
That's what they do in Rust. I see
what
that
they
a
also
lot.
do in Java. Java has, I can show that real quick, hold on.
No. No. We don't show that on this stream.
Behold.
Oh.
Come on, Oracle, get lost. Behold.
The fireplace.
Constructor. That's what you do in some languages. Yeah, this is what happens. You want to create a map with more than 10 mappings? Sorry, you can't. There's 10 overloads for this.
So ridiculous.
Yeah, 11 actually. So yeah, that's what they do in some languages. That's what you'd have to do before C++. Can't think of a way of doing this better in C++11. The only other way, no, you can't even do this because these are types. If they were values, you could use C-style varargs, which are horrible in their own regard. But these are types. You can't even do anything with that before C++11. So luckily, since C++11, we have a solution to this problem. Let's put this long here back. The solution is variadic templates. What we can write now is copy this abomination here. Let's just rename that to is variadic. And let's
confusing.
Make sure that we're using that down here. So first thing is, what you can do in C++ is instead of, so this is C++11, instead of this abomination here, we just create a number of A's. We create a pack. So this syntax, dot followed by a name, introduces a pack of types. So here in this call, A's is these 5 types.
Name it A's.
I'm going to rename it in a second.
Can you name it T's?
Don't worry.
At least.
I will rename it in a second. Just don't worry.
Please.
So the problem is with that, how do we iterate over this? Ideally, we'd like to be able to just write a for loop, but unfortunately, you just can't do this.
You're gonna recurse, I think.
Exactly. What we're going to do here is we're going to take a page out of Lisp's book, and we're going to write this. If you, as a Lisp programmer, this should look familiar to you. We split the list into car and coda, or first and rest. And then we can do, we can call one variable is from up here, or one type is. If it's the first type, we return true. Otherwise, just call ourselves again.
Someone's requesting to force you at gunpoint to explain standard move.
Oh, no.
References, I will. So, and you have to put ... here because that's how you use params. So what this does is, for instance, if I call it, ignore that, I'll talk about this in a second. If we pass in this in here, then on the first call, first will be int, rest will be the rest. So we check if it's an int, if it is return true. Otherwise, we just call is variadic these. And then that just goes on and on. Okay? Does that make sense?
Okay.
There's only one problem. This code doesn't compile. Let's take a look at why it doesn't compile. It's helpful to read error messages. So in the instantiation of is variadic, that's this function, with first is long int and rest is empty. So this tells us that this is happening when we recurse and recurse and recurse until first is long and rest is empty, because a pack is allowed to be empty. And we're trying to instantiate is variadic with no arguments, because if we're passing in all of this, right, eventually we're just going to get down to, because we recurse, we remove the first type at every step. Eventually, first is just going to be long, and rest is empty. Okay, this still works, but then we try and call variadic with an empty pack, or rather with no type at all. But then in this instantiation, what is first supposed to be? Because we have to provide a value for this. So the problem here is our recursion has no base case. It's just falling off the end. So we have to write a base case for our recursion. And the way you do this is, with an overload. You add an overload. If there are no parameters, if it's just the variant, we just return false. Now the code compiles.
So
This is how you do it in C++11.
Can I try
The
and
recursion and the base case.
summarize? So it's confusing how it's named. Is variadic does not check if it's is variadic. It's just is. It's just is. Isv is good enough, yeah. It's just the variadic version of is. So we're
Variadic
checking.
implementation of is.
So it takes in one variant, right? A standard variant.
It's passed here.
And then basically it says if is on the first of foo, return true. If not, check the rest of the list if there is any. But if there isn't any, it will be empty, in which case we'll fall through to the overload, which has no template parameter pack because it's empty and it expands to nothing. And we end up with just the variant, like it just knows this template because we're passing it the same parameter. And
yeah, the variant template parameter is deduced from the argument. We're not specifying that explicitly. These we are specifying explicitly.
And if we get through the entire parameter pack and none of them have returned true, then we return false because it's not any of the types that we passed to the template it is. And just going over something, what is the ...
So the way this works is ... to the left of a name declares a pack. So this declares a new pack of types called rest. And to use a pack to expand, you need to expand it. And expanding, you do that by putting the ... on the right. So what expanding on a pack does is this just if for instance if rest is A, B, C, and rest inside of a template argument list just expands to A, B, C. What the ... does depends on the context. In this case, it just expands them and puts a comma in between. The same thing happens if you put it in parentheses, if it's not, because you can also have packs of arguments, not just packs of template arguments.
It's kind of a similar mess to the asterisk.
Yes, sort of. It is a bit, this notation, I can see how that could be confusing.
It's
Is it clear how this works? Not just what it does, but how it works.
To me, because I have Lisp, I can kind of map this to Lisp knowledge and like, oh, this is just a fold. You just wrote fold-L. But I think it's understandable enough.
Good. So this is still annoying though, because we have two functions. So every time we need to do this, we have two functions because we need to specify the base case here. It would be much nicer if we could just write one function. And so since C++17, we can. And this is, there's two versions that I'll give you for C++17. This is version 1. So we start with this.
Zoe, yes, thank you for the follow.
I'm going to rename that to CXX17.1 because that's the first version. V1, so that it's not confusing. We're going to make sure that it calls itself. Jesus Christ, I didn't mean to do that. Make sure that it calls itself, and we also make sure that we're calling this down here. So now we're back to the error because we have no base case. This part can still be the same. That doesn't change. What we can do now is we can put the base case in here. So what we'd like to do is we'll write something like if, and then in here the size of rest is, if that's 0, just return false. Otherwise do this. Since C++, I think 11 even, there's an operator that gets the size of a pack. And it's, you're not going to like this, it's size of ... rest. That is the name of this operator. It's size of ... That gets the size of a pack, and the size of a pack is the number of elements. If that is 0, we return false. Otherwise, we return rest. And the problem is this still doesn't compile, and that's because this is a check that's there, but this is still being instantiated. It still tries to instantiate that because the code is there, even if it's not going to be reached. So the way you can stop it from doing that is by making this a const expr if statement. And the semantics of if const expr are, this condition is checked at compile time. If it is true, then this code is
well, it is compiled. Otherwise, this code is just thrown out and not even type checked.
It's like an if-def.
Sort of, yeah. It's like an if-def, but it's as part of C++. This still doesn't compile, and the problem is that this if const expert just says, okay, if this is true at compile time, then we just return false. Then this code just gets so if rest is true, then this code just gets inserted here. If this is not true, the entire thing just gets deleted. The problem is, either way, this is still here, so we need to tell it to remove this if this condition is true. And to do that, we simply put else here. So with if const expert, you often have to use else to tell it, okay, if this is true, keep this branch, but discard this. If this is false, discard this, and keep this. And as you can see, it compiles. We only need one function now. So we can specify the base case directly in the same function. All right, this is...
That's very cursed.
Does this make sense?
Yes, but it's kind of cursed. Why is size of ... Why do we need ... Why can't we just do size of rest?
Size of rest gets the size of a type is the problem. And this isn't a type, it's a pack. And a pack is basically just a separate kind in C++.
And because
it's an entirely different entity, simply because of that's how it's implemented. There is no good reason why you... I mean, the thing is, size of rest kind of has different semantics, because this size of gets the size of a type, this size of gets the number of elements in a pack.
So what you're saying is the C++ committee is so... has their head so far up in some discrete places that they won't add a new keyword to get the length of, for example, a parameter pack.
Can call this...
Length, or just length of. Yeah, that would make much more sense, because it's not the size of anything in memory.
That's just the problem that C++ dislikes like making new keywords. It just likes reusing old ones in novel ways, or using the same ones for different things, so long as it's not ambiguous technically.
Yeah, it's technically correct.
It's literally just called the size of ... This is one operator. It's just called the size of ... operator.
Fantastic. Two-Step says, hello, what kind of dark C++ arts are we exploring here? Parameter packs?
Packs and variety templates.
So
yeah, but does this code make sense? Does it make sense how we got from this to this?
It makes sense how we got from that to that. I'm kind of confused as to how... So in C++11, couldn't you... Oh, I see. No, you can't. Because of the rest...
There was no const expert if in C++11.
Yeah, that's the issue. Because if there was const expert if, you could do some callback stuff. And you could have each is pass in its base case. Not that you'd want to do that, but...
Yeah, typically in old C++, and C++11 is actually modern C++, but it's barely modern C++. It's when modern C++ starts. But yeah, back then you had to write it like this. But at least we had variety templates. Because before that, it's this nonsense.
I dislike C++11. I enjoy before it and I enjoy after it, but C++11 is not.
Is this enjoyable?
Yeah.
No, this is horrible, because if you want to pass in 10 types, you'll have to write a new one. Whereas here, you just use the same one.
I mean,
you have to do that all the time, though.
Yeah, you're right.
To pass in a variable number of types. You don't just write one function that checks 5 times at a time and only 5 types. That defeats the point of having this function.
Which
is supposed to be so you don't have to write this all the time. And the premise is that you have to write to check for multiple things all the time, which you have to do that in a compiler. I had to do that all the time. It's like all over the place, checking for, is this one of these things?
Yeah, that's kind of every...
And if something just happens all the time, you want the shortest way of writing that, both writing it and implementing that.
So, I thought I had a good example, but I forgot what I was going to say. It had to do with like the M-code functions. How there's in the generic object. That's right. So I wrote this generic object file API so that any object file syntax can or format, I guess. Syntax? That's kind of weird. can be we can just transform our generic object file into that. We don't have to produce like 18 different backends for every object file. We just have one object file backend and then transform into the different Mako or ELF or Cough.
You can definitely write a function that accepts a variable number of arguments and just writes those.
Right.
Yes.
So I had to do exactly what you're describing, where like if I want to pass 1 byte, I wrote the function to do that. If I want to pass 2 bytes, I wrote the function to do that. If I want to pass 3 bytes, I wrote the function to do that. And I just went up to 4, and I never needed more than that in like assembling machine code. But this is terrible. And because it's just literally how many times am I calling a function? It's pretty stupid. So what you're saying, could we do this with parameter packs?
Yeah, we'll do that after I'm done explaining this. We'll do the same thing again, starting in C++11, but with printing numbers. That's a good idea. We'll do that.
Beautiful.
There's one last evolution of this, and it's the version 2 that uses fold expressions. And for fold expressions, I've written a few things down here. So a fold expression. Okay, I need to like pull this back.
Perfect.
So fold expression, the syntax, this is like BNF, is like this. You have an expression that's surrounded by parentheses. It contains an expression, an operator, and ... So an example of that would be...
Can you use new?
Can use a new expression. No, and it has to be a binary operator, sorry.
Okay.
It has to be a binary operator. So, and also not any, like you can't use the arrow operator, pretty sure. That doesn't make sense.
That'd be a little
odd. If we have a pack of, in this case, we have a pack of arguments and not template arguments that contains 1, 2, 3, 4, and 5 was my intention here. And if we just have this fold expressions here, integers plus 3, that's x per here. Binary operator is the star. We have ... here, and we have the parentheses around it. That expands to 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5 plus 3. Does this make sense?
No.
So
what is it? So the expression on the left, integers, can be like however nested it. Like, can you add another set of parentheses, integers plus 3, and then parentheses around that and do integers plus 2 around the plus 3?
Using the same pack multiple times, that's like...
Not multiple times, just using once.
Well, you can probably... God, I'm using the wrong key bindings all the time. It's horrible. You can probably do... I'd have to check that real quick, but you can probably do something like this. That would just be times 2, sure.
Yeah, not like that. Same. Like integers plus 3, and then just put more parentheses around that. One more set around integers plus 3, the current parens, and then add plus 5 in that.
Sure.
I think you can.
So you can just put integers anywhere on the left-hand side in one spot, yes, most likely.
Yeah, I forgot to read this. What expression contains an unexpanded, that's important, so no ... here, just integers.
So it's just implicit expansion?
Expansion happens over the operator. I'm getting to the part. So what this does is it takes this expression that's here. For each pack element, it substitutes that pack element, and then it takes all of these expansions and joins them together with this operator.
So integers automatically gets binded to the elements, each element of the list?
This is like a funky
integers is this entire pack here.
Oh, the entire pack. Okay.
The entire pack is integers, yeah. Pack, yeah. So integers is this entire pack, and if we say it contains, let's just delete it and expand it manually. If it contains 1, 2, 3, 4, and 5, then okay, we grab this thing, this expression here. That's this thing here. Paste it. We insert the first member. I copied the wrong thing again. This is horrible. Wrong key bindings. Copy this. That's the expression. That's just what the compiler is. Literally just copies the expression, basically, the AST. Insert 1 for integers. Okay?
Oh, I see.
Then we do that for all of these, okay? We take this again, paste, insert 2. That's the next pack element. And then we keep going, we insert 3, we insert 4, because that's the next element, we insert 5, and then we have all of these like AST pieces, and what we do then is we join them with the operator.
This is
Has to be a
functional
binary operator.
programming.
Yeah.
It's a fairly complicated operation, this thing.
It is. You're describing map, which is using foldil and foldar, and this is actually foldar because it.
Yeah, something like that.
You just implemented foldil and foldar in C++, and
Call
that's
the fold
is.
expression for a reason.
It makes so much more sense, man. Thank
So
you.
can you just assign this to a variable? Can you just write
Yes,
auto
you can.
I equals?
That's what we'll actually do in a second. So we can rewrite this with a fold expression. And what we'll do is... I copied the wrong thing again. I forgot to copy the template argument list. So let's call this v2. We'll delete the body because we won't need it anymore. v2. And what we will do now is we just apply this fold expression. We don't even need the first thing anymore. We can just grab the entire list. What you can do now is this. So we have some expression, some operator, and ... And the expression is going to be just our is call. So we call is. That's again the type. On foo. The operator is, well, it's operator or, isn't it?
Yep.
That's what we want to do. And we return that.
And that's kind of easier to see this one from the original pre-C++ solution. Because we're just we're taking the is or, right? And we're just writing,
And this
that's
has some benefits.
Such a bad syntax.
First, it's shorter. Second, you only have one instantiation and not like however many arguments there are. Because it doesn't recursively instantiate, it just evaluates it here.
So it's much faster. It's probably quicker compile
It should
times.
be faster to compile, yes.
Yeah, much faster. Because
it's also much shorter. If you know the syntax, you can look at this, you immediately know what it does.
Yeah.
And that's also the difference between, because you asked you asked me sometime why the ... is needed. It's needed in this case because this has very different semantics, because that's just taking all the arguments and pasting them in here. We don't want to do that.
Yeah,
we want to instantiate this entire expression for each type.
So we're kind of using the binary operator as parentheses for the expression on the left that we want to fold. And then the binary operator is also serving not only as a delimiter in the syntax, but also as the operation that we are mapping to all of our different elements in our list. I don't think I've ever understood it that deeply. That's fantastic.
And there's just a few little things that are fairly easy to explain. For instance, of course, this is a lazy evaluated or, obviously, but if you have some operator like plus and the order doesn't matter, you can put them the other way around as well. You can also do it this way around. For instance. The semantics are like one of them is fold R, the other one is fold L. Like one of them is associated like A plus B plus C, and the other, I always forget which one it is. The other one is A plus B plus C. So one is one way around, one is the other way around, depending on whether you put the ... on the left or on the right of the operator.
Yeah, you're just describing foldil or foldar.
Yeah, so you can do either one.
But there's no initial value.
There is no initial value here.
What if types is empty?
Good question, I was getting to that. That depends on the operator. Typical, that's not allowed, but there are special cases, and one of them is or. If it's empty, you can do that. In that case, the entire thing just evaluates to false. To false. If it's and, it evaluates to true. That's just how it's defined. That's literally just quote-unquote hard-coded.
Yeah, there's no reason. Yeah, it's just like...
There's no reason other than this is typically what you want, like empirically.
Yeah.
And you can always convert it as long as it's known.
Yeah.
Okay. Well, that does demystify that a lot.
You can do that with any operator. We'll go over this entire thing again, but we'll implement your print nums function. I'll omit this case because you've written that one. So in C++ 11, could do something like this. Numbers. And you'll see a new thing now. And this just prints all the numbers, okay? Print nums. This does two things at once. This dot 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 basically expands this pack and it creates a new pack here. Which means basically for each type in numbers, create a function parameter. And all of those parameter values are grouped into another pack called numbers.
It's kind of like we're letting the actual values we get passed in through the template, we're like binding that to numbers.
Mm-hmm.
So that gets us like the actual unpacked template parameters, whereas numbers itself would just be the template parameters. Like, what's the difference between capital numbers and lowercase numbers?
This is a pack of types. This is a pack of values.
So what's the value that it gets assigned to, for example? Like if you have int, short, unsigned, long. Oh, numbers. Never mind. I get it.
Let's print some numbers then.
Yeah, I'm getting it now. I was thinking that we're passing types to this thing, but we're passing numbers to it, and this makes much more sense.
In this case, numbers is int. It's just 5 times int.
Because of type name. Okay.
Mm-hmm. If we did this, it would be int unsigned, int.
Okay, that makes a lot of sense. And
numbers is just going to be literally 1, 2, 3, 4, 5. It's these are the parameters.
Okay, I get it now.
In C++11, you do it this way. So we'd say format print. We'd have to split it again. First, best, first, numbers, the rest. And then just print nums. And you can also expand, we mentioned that earlier, you can expand packs also in parentheses. Of course, it's complaining because there's no base case, so we have to add that one. This should just be like this, I'm pretty sure.
Wait, does it catch that at compile time? What?
And let's like print Sorry, what was the question?
What did it complain that there was no base case? Was that the error?
It tries to instantiate itself with no parameters, but then it can't derive the type of first because it doesn't know what that's supposed to be.
Okay, yeah, that makes sense.
There's also just no parameter for first, which is a mandatory parameter, so it just doesn't like that at all.
Yep. This happens at compile time anyway.
Wow. So you printed 1, 2, 3, 4, 5.
Mm-hmm. But this is the C++11 way of doing it. We can do better. So with const ref, you can I'm just gonna delete this now. Or I'll leave it here, but I'll just do 2.
Fantastic.
Now we can do the good old if const expr thing, and here I just do if const expr size of either rest or rest works here. It doesn't matter; they have the same length. Not equal to 0, then we call ourselves again. Otherwise, we don't.
Ooh.
That makes sense.
So that's the same thing we did earlier, where we're just getting the length of the parameter pack rest.
Mm-hmm.
And then if it's 0, we're doing that at compile time because of the if const expr. Mm-hmm. So print nums2 won't get quote unquote instantiated if that's false. Oh, fantastic.
So that makes sense.
It's such a hack. It's such a hack. It does make sense. I see it, but I can't think of a better way, but it just feels dirty.
So there is a better way. We can use fold expressions for this.
Yes.
Think of an operator that would help here.
That's what I was thinking about.
What operator can we use? It's not one that's used commonly, but it exists even in C.
Are we going to overload one and just use that?
Nope. There's a built-in one that we can use.
Huh.
Okay, this might be stupid. I don't know if comma.
We can use the comma operator, yes.
Oh my god.
If you don't know the semantics of the
Numbers.
comma operator, it's not commonly used because the semantics is just if we have some int foo and we assign 2,3, the comma operator just evaluates all of its expression. Are we redeclaring foo? We are. I somehow picked the same name. It just evaluates all the expressions and returns the last one.
So bar's 3.
It's just discards
And that's
2.
used in like if expressions a lot. If conditions.
These are
Oh,
expressions.
yeah, right.
So it's the comma is basically the semicolon for expressions.
Yeah.
And a common use of this can be in in C, not in C++ really, but in C. If you have if x equals 4 and you actually want to assign something to it, then compilers will complain because that's a common bug. So some people write this. What I like to write instead, I like to write this. That's equivalent. That evaluates this and then returns this. Or in while.
Also,
I like to write.
yeah.
I like writing that in C or C or C in C. Not in C++. You don't need it because you can just declare x here, as we showed earlier.
I feel like
but
you
in
just
C, you can
spoke
write
the
this, for
amen
instance.
break.
That's like the only use of the comma operator I can really think of in C, or maybe if you're doing some cursed macro shenanigans.
I see it used in return statements. It's similar to if.
Yeah, for instance, like return do
Yeah.
something
Comma x, yeah.
true. So, for instance, you could do something like that.
Yeah.
I
Messy.
typically wouldn't write this sort of code in C, but you can. What it is very useful, though, is it is a binary operator, which means we can use it in a fold expression. Which means what I can do is I can do not that.
Yeah, this is even more hacky.
I can print numbers and then just I fold over the comma operator. That's it.
The parsing of that hurts my head. How is that not a comma expression?
That is not a comma expression because of the ... because that's the next token.
Ah, yes, look ahead. Love it.
C++ does that a lot. There's a few things to keep in mind here. For instance, the expression that you're folding over, that's one thing I've mentioned. If it contains an operator with lower precedence than cast, so if you have like a plus in here, you have to put another set of parentheses around it.
Which makes sense.
Yeah. So for instance, if you wanted to, if you return an int, if you wanted to just, I don't know, what should we call this? Thing like square and add, and we just want to square and every number and add all the squares together, then we could do something like pretty much we can do numbers time. If we try to just write numbers times numbers and then plus I think you can see what the problem is here, why it doesn't want to do that. So instead what you numbers times numbers, so instead what you have to write is you have to put parentheses around that, otherwise it just doesn't like that sort of parsing. And now obviously we can...
Rarely, that's a time in C++ where they disallowed something and made it an error so that you don't shoot yourself in the foot.
Yeah.
I'm just mad you didn't call it squad.
Square!
So now the sum of the first 5 square numbers appears to be 55. So yeah. And it's for these sort of operations that fold expressions are pretty useful for, like these sorts of things. If you need to just and what you can also do, a little trick is you can, if you have you can define a lambda, do something that takes in some int x and does something with it, and then you can just fold over that lambda. Like if we do, like you can do
that's
this. That can make it more readable if you have something long. A lambda is like this, but yes. Yeah, you can do that, for instance. That's something I do sometimes if I need to fold, if I need to run a lambda on every member of a pack. You can do this.
Is there a reason they didn't just make this a part of the for loop or for each, or?
There are some meta-programming proposals that have you write something like template for, I think it's type name,
Oh, Jesus.
a number in numbers, whatever, and then you can do some stuff with it here. The problem is that this has to be instantiated for every member of that. Or I would write for const expr. Or there are some proposals that do this. It's like any sort of syntax that just lets you write that as a for loop. That's very much what we'd like to be able to write, but there is currently no way of writing that because the semantics of that are simply a bit complicated with how you have to instantiate the code once for every member of the pack. So it's not just as simple as just implement a for loop.
Wacky.
Can't you have like iterators or something? I don't know, I'm just saying.
Packs are very weird because they're these compile time things that don't exist at runtime fundamentally. They're compile time only
like templates.
Entities is the word I'm looking for. And there simply aren't a lot of operations you can do with them. You can call size of ... with them. You can pass them into a function argument list or template argument list. You can do folding on them. That's pretty much it. There isn't much more that you could derive from them. That's something you can do. Bases. That's another operation. That this is very rarely that you need this. You can do this. You can derive from a pack. I use that in my command and options library for like stuff like this is mostly just for metaprogramming. If you just need to combine structs in a cursed manner for metaprogramming things. So this is possible, but in real code, I don't think you'll ever see this really.
I think this is
something
where
you can do with packs, but that's pretty much all you can do with them. Can't really. Maybe there's some rare operation that I'm missing, but typically the only thing you can do with packs is expand them in some controlled manner or take the number of arguments. That's it. They're really limited in what you can do with them. That's why it can be hard to work with, and that's why fold expressions all that exist, so you don't have to write this or this. That's why I said that, I think last stream or sometime before that if you just look at this in a vacuum, it probably looks weird to you. But if you consider that this is just a shorter way of writing this, which is a shorter way of writing this, which is just exists so we don't have to write this, which exists so we don't have to write this every time, I think you kind of start to understand what this means. And I think also for you as a Lisp programmer, it kind of makes sense to draw connections between that and functional programming. The thing is, template metaprogramming and this sort of stuff is very much functional because it relies a lot on recursion and stuff like that.
Yeah. I guess this is where having types as expression would be very useful.
Yes.
Yeah.
Very much. So, any more questions about fold expressions, const riff, or stuff like that?
Oh, I hope not.
Yeah, if anyone has them in chat, put them now, but I think I'm good.
Pretty much talked about everything there is to know about fold expressions. You now know how to use fold expressions, basically.
I'm going to put laundry in the tags of this video.
I was going to say I just did my laundry. I should have waited.
We're going to be so good at folding.
Let's go.
Oh, and one last thing to make this even shorter. Hold on, where's the... I need to undo a few things. Back to where we had the print nums thing. What you can actually do now in C++20...
Oh no.
You can make this shorter.
X++.
Because C++20 added abbreviated function templates. Now you can just write auto in here.
Auto, yeah.
That is implicitly a template. As soon as you have auto in the parameter list, that behaves the same as though you had a template parameter for that.
But I saw you using in your code auto in the return parameter. Is it the same thing? Is it also a template?
That's different. That's a deduced return parameter. That's the same. So basically, auto foo returns t is the same thing as t foo.
You do that for scoping, like if you need to know what is in like the parameter list or something with the return type, you would want that because sequential whatever C++ jargon.
Something like this.
Turns out I'm tireder than I think I am and I can't construct sentences, so I give up. You can explain it.
Yeah, this isn't in scope here. You can't use t here because t has not been, or bar here because bar has not been, like, I don't know, deckel type bar plus what you do, whatever.
There you go, yeah.
So you can't use bar in here. You can't write deckel type. Heckle type bar. Oh my god, I'm copying the wrong thing. It's because I'm used to Emacs key bindings and Compile Explorer doesn't have them. So, but you can't write tbind here because bar has not been declared yet. That's why this syntax exists. That's why this exists, because it's so you can refer back to what's declared in here. The reason why I use it is a very different one. I just like that it lines up nicely.
Yeah.
Because if you have a long type name here, then it just everywhere. Whereas if you have auto everywhere, then it just lines up nicely here. That's the only reason why I use it, and that's also why you'll only see me use it if the type name is longer than 4 characters.
Yep.
If it's bool, I'll just write bool. If it's void, I'll just write void.
So you can't actually omit.
Sorry, come again.
So when you use auto in the return type, you can actually omit the type hint. Trailing return type.
Just have a deduced return type. For instance, I can just have int x and return x.
Okay, so you can actually do that.
Returns an int. That's deduced.
Okay.
And if you have like, if x is 3 return 4.f, now you have a conflict. Now it will if I remove this nonsense here. And now it should. What am I doing here that it doesn't like?
Inconsistent deduction. It's got.
It's complaining about this, and that's why this is probably failing. I called it print nums3. That's why. There. So now you can see inconsistent deduction for auto return type, float, and then int. Ooh. So it has to. If you have multiple return statements, it has to be the same type. But you can deduce it this way. Yes, you can do that.
Two-Step asks, why are you guys discussing these C++ features? Is it for a feature or something else?
It's because we're moving the compiler to C++ and will likely be, for instance, the is function that I mentioned a while back that's going to check if an expression has a certain type is more or less going to be something like this. It's basically going to be just a default expression.
Yeah, so this stream, towards the beginning, we went over how the compiler's just about to change and what our plans are. And now we're going over some more details about how these actual changes are going to be implemented. Because I'm not the best at C++, and I didn't want to just be entirely confused reading code.
Education.
Exactly. So yeah, we're going over C++ just so that I don't lose track of the development.
I have a short write-up of just this stuff here. I'll put that in. I can put that in like actual Godbolt and just make a public link for that in case anyone wants to look at it.
I'll put that in the description if I have it.
Should I do that now or later?
Perfect. Anytime. It doesn't matter.
I'll do it later then. So, any more questions about fold expressions? Because if not, we're going to move on to references if you still have time for that. If you're comfortable going for at least another half an hour.
I don't have time for that. I have 10 minutes.
10 minutes. Oh, that's...
Save it for next time.
That's right.
Yeah, it's probably for next time then. I'm also not entirely done just writing this down, so that would be better, probably.
Perfect.
We're going to talk about value categories next time.
Value categories? What?
Oh no, he doesn't know.
Values and so on.
Yeah. PR values, GL values.
Because someone asked
X
about
values.
standard move, I'm going to explain what standard move does, how it works.
Ooh, good idea. Yes. That's perfect.
I only thought there was like 2 categories, like the R value and the L value.
That was before C++11, and in C is R value and L value. C++ extends that and adds a third category, that of an X value, and it also it has 5 categories actually, but 2 of them are just like overarching.
My lord.
L values, GL values, X values, R values, and PR values. We'll go over all of that. It all makes sense if you understand the history. But again, in order to understand this, you have to understand this first. And it's the same thing with X values. You can't explain X values without understanding how R values work in C++.
Yeah, just getting L values and R values down is the start for everybody.
Yeah. There's more to them than just the theory that you probably know in C++.
That's how C++ always works. There's always more than you know.
Surprisingly, that's not a language abstraction. The reason why value categories are so complicated is so they can more accurately model the underlying hardware to allow for more performant code gen and all of that. So that's actually just a low-level thing.
Oh, okay.
Oh man, I'm excited.
And
Woo!
value category is
Same.
also not something that really exists in the language per se. They are only like in the they do exist. They're part of the standard, but they're not a language feature. They're more of a consequence of how the language is.
It do
They
be how it
modeled
Yeah.
the AST somehow.
No, they don't really have anything to. That's not really. No, I'll explain that next time how value
Okay.
categories
is.
work.
No more.
Yeah.
Because I have to explain the entire thing for that to make sense. Yeah. So
Move, standard move.
and standard move, we'll explain that. Because standard move just converts something to converts a GL value to an X value, basically.
So stay tuned if you're interested in figuring out what standard move is. And standard forward, you're gonna have to follow or go subscribe on YouTube. Did you know the
we can
YouTube?
explain forwarding references after we've explained value categories. They don't necessarily have anything to do with each other, unfortunately. But the thing is, you'll understand the motivation why forward exists once you understand how value categories and how copying and moving works. Because you have to understand what our value references are, and for that you have to understand what value categories are. So
I always wanted to know more about this.
we'll go over value categories, standard moves, standard forward, universal references, and all of that. And also why we recommend writing const reference all the time, because that's not just because of const correctness. There are other reasons for that. Const correctness is what you teach because that's easy to teach. You teach them if someone asks, why do we pass by const reference? Because we don't want to copy and because we don't want to modify it, so a const correct. That's the reason, but that's a good reason too, but there's another underlying reason.
Is it up with calling convention stuff? I forget.
No, it's to allow passing in temporaries because const reference can bind to
There you
temporaries,
go.
whereas
That's
normal
why.
references can't, and the reason for that, we'll go over that.
Yep. No more questions.
Hey, it's Zyguy. Hi, Zyguy.
And if you have questions about something else that's easy to explain, or about fold expressions or variance or const expirif, I can answer that now, sure. But value categories are an entire thing that's
That's gonna be a
Wait,
little bit.
talk about.
Can you overload the comma operator? That would
Yes.
be nice.
Yes, you can.
Oh, God.
Ooh, that would be crazy.
Because there aren't many uses for that, typically. Can do it. The only reason why you do that is the comma operator has the lowest precedence of all operators. So if you need it for some reason, they do it. That's also the only reason why you'd only ever overload the member to pointer operator. Pointer to point. What is this? Is pointer to member of pointer, whatever it's called. This is not an operator you'll see too often. This and this.
What?
I understand what they're for, but God,
Yeah.
I don't like that they're there.
Yeah, they're very rare. I use them in a wrapper library around, or something that's part of a wrapper around basically V8 to facilitate instantiating object templates and just automatically assigning stuff in templated code. That's like, that's a use I've found for pointer to member, but they are very rarely used operators. But this operator has a very high precedence, the same as this one, basically. I'd think it's a bit. I'd have to check what the precedence is of it, but it has a very high precedence, so you can use it if you need something that binds tightly, and you can overload it. So the only reason why you typically need these is why you would want to overload these is because of the precedence. They don't really have any semantical import for which it would make sense to overload them. It's not like, okay, with plus you add two things together conceptually that makes sense. With this operator or even the comma, not really. You only pick them because of the precedence.
I already want to start writing my Laia front end, but I kind of gotta wait for you guys to be ready to refactor, which is going to be at least another episode.
Well, we'll probably start off stream, so.
Yeah, these refactor and rewrite streams are going to be like going over what changed. They're not going to be a lot of writing. Because all of us are going to be doing it.
Jump in.
Exactly. Yeah.
Yeah, so basically what I'd like to do first is just like layout, basically just we'll have to change the CMake list thing a bit.
Yeah.
I'll have to separate the drive and the library. I'll like do basic name spacing. Like, do we
LCC?
want to, okay, one last thing for naming conventions. Because you like using Pascal case for type, I'm assuming we're going to do the same for classes. For function names, do you want to use snake case or Pascal case? I am not willing to do camel case because I hate it.
Camel case reminds me of JavaScript, and JavaScript can go die in a hole alone. So
Camel case
we'll
reminds
avoid
me of
camel
Java,
case.
and Java can go die in a hole.
Yeah.
So I think we agree on that, but for separate reasons. So
Very
would you like
accurate.
Pascal case for functions or snake case?
I think a snake case is what I prefer for C++,
Sure, we can do that.
Same.
just because
For-
types and functions are it's good to distinguish those clearly.
Mhm.
And it matches the standard.
Yeah. For members, there's two options. Either prefix them with something like an underscore, or we'll have to prefix like all function parameters with underscores, or just disable shadowing. That might honestly be an option because you just get the problem with W shadow is that it does catch bugs, but it also has some fundamental issues. Like for instance, I'll show you one. Hold on. I'll turn on W
To
shadow.
answer the question on my end, I'm used to using just an underscore for members when I program in C#, so that's my preference.
You could do that, or just use the same name, because the thing is about W shadow, I'm honestly so tired of it. I'll show you why.
I'd vote to disable shadowing. And then have a convention for if we have a parameter the same name as a member, we always do one sort of thing.
Yeah, I'd just rather not have shadows anywhere.
Exactly.
It gets
Well,
confusing.
int X shadows a parameter.
What?
It does not. This lambda doesn't
That's not a-
capture X. There's no way that this could shadow this. But Jesus,
Yeah, we're not going to have that happen that often.
Bugs.
No, yes, you will. It happens all the time.
It
Lambda.
does.
It is so fucking annoying. You think it wouldn't, but
The
no.
parser.
Maybe it's not X. Maybe it's I. You just want to call it I because it's a lambda that has 2 lines. Now I was defined 30 lines up. You can't use that
In a for
okay.
loop.
Maybe, what about, I'm now dealing with expr. No, expr is taken. Okay, E is taken for something else, but this doesn't even capture it. Sorry, no, it's taken. You can't, it's annoying. It's horrible.
It's in the wrong scope.
Is way too aggressive. Like, this is just wrong. There's no way in which this, if it now it has any right to shadow. Sure, or now, because now it captures X. Or now it captures X. There are no captures here. If I use X in here, this X can only ever be this X. There's no ambiguity. I'm fine with it warning. I would be fine with warning if I'm at least capturing stuff, but I'm not.
It's just a separate
just
scope. It doesn't make any
incorrect.
sense.
It's just wrong. The warning is just wrong. And I think it's not just Clang is the same thing. Okay, Clang doesn't like
Am I old?
23 after the 2B. But I think Clang has this. I'm not sure if Clang has the same. Clang has the same problem. Clang also warns about unused parameters. Hold on, that's like a different warning. I need to turn that off. W no.
Am I old?
Parameter. Does Clang warn about it?
Does
Actually, I
nobody
haven't
know what
tested it in a
Dragon Ball
while.
Z is?
Clang doesn't warn.
Let's
It's a
go,
GCC
choose
problem.
Clang.
It's a classic. It's a GCC problem.
Yeah, that is a
Can you try
class.
to,
saying
can
it's
you,
a
can you try
classic
to capture?
because
Can you try to capture by value? Can you try to capture the X by
By
value?
value, it's probably going to complain. Oh, it's
No,
not.
it's not.
Capture by reference. Because
Sure.
I'm using
Oh,
it. Let's
no.
just do,
Oh no, actually no.
X. Oh, it just doesn't care.
No, it shouldn't. It shouldn't
In that
actually.
case,
Oh,
it's difficult because, I mean, yeah.
So they
in
both
fact,
go too far
actually,
in either
actually, no.
direction.
Actually, you're not capturing anything in this lambda. Nothing gets
I'm
captured.
capturing
Actually,
everything by reference here. This is just resolving to that, but at that point, yeah, there's
Yeah.
2 X's which could possibly be like, if I do this, like, okay, you can't have a, that's
Yeah,
the
that's-
simplest thing.
that's
You
no.
can't have a parameter with the same name as an explicit capture. Sure,
that's fair.
but this is okay. No, interesting. It doesn't. Oh, because of a capture. Like, hold on. That is a weird behavior. This is like a horror. Yeah, this is a horrible edge case. You can't do that. You can't capture it explicitly and declare it as. I've run into this before. That's something you can't do. But I can just implicitly capture everything by value. In which case, this warning by G++ is correct. This could be either. Yeah, it's like at this point, it's semantically difficult to define whether this counts as capturing. Either way.
No, you're not
G++
capturing anything.
should not warn for this because there's no way that this ever captures this X. This is just wrong. The other case we could
wrong.
argue either way, but this is just wrong.
Yeah, that's fair.
So that's why I'm honestly really debating turning off shadowing because it's just too goddamn annoying. Like these cases, you think they don't happen all the time, they do. They are so common. It is
Okay.
so annoying.
It's true. He's right. In C++,
Especially
if
for,
you ever
like,
think it won't happen, it will.
Instruct especially.
I don't need more examples. I get it. Does chat need more examples? Lens has got to go. It's been 12, 13 minutes. Get out of here,
I
Lens.
planned for
Run
that.
away.
I know. I still have 2 minutes before I actually just have to click the button and leave. So there's time for an outro.
This is fairly common, and the thing is, it's not just this. It's also just if you have some thing called size and you have a function parameter called whatever. It's like cases like these, especially in constructors, are just very common.
Yeah, well, that's why I said.
Oh, yeah.
Underscore.
Yeah, okay.
Either you have to do this, and this is annoying.
Yeah.
Or you have to do this, and then you have to use the underscore everywhere you use the member. Either way, it's just annoying. It just really is annoying.
It is.
So,
There.
if you could turn off shadowing just for here, just for like the initializer list and enable it in the body, I'd probably be fine with that. And if it also could just turn off this, if those two things were fixed, then probably I'd be fine. I'd consider really enabling double shadow, but I've disabled it now in my project simply because it's too goddamn annoying. Also
There's
because,
an annotation, maybe?
no,
probably no?
no,
Okay.
there is no. I don't think there's no attribute for that.
There,
And also,
there's one for sanitizers. You can
maybe
disable
there
it
is
for one
that could be the
function.
case.
All
But
right.
for like G++ is just too aggressive here.
I'm gonna
Clang, actually, that's an interesting question. Does Clang
do the
Clang
things.
one here? It probably.
Yeah, we gotta go. We gotta go.
Will I?
Clang does.
I can either mute or
Turn
not.
up shadowing.
Yeah. I also have to go get myself some food.
Right.
We are humans after all.
So yeah, we're
Totally
gonna
all
talk about this
humans,
next round.
not robots.
And about categories.
Next time,
Next time is when? Next Sunday again, or earlier, or later, or?
ideally, it'll be sometime in the afternoon this week. Like what time it is now, it'll be like starting at this time.
Sure, that
Sometime
works.
on a weekday.
That works for me.
If it's
If
Tuesday, I
you
won't
don't have-
attend.
Is also if you don't have that much time, you don't have to do like a 6-hour stream. You can just stream for an hour and a half or whatever.
Yeah.
That
Yeah.
also work.
That's the kind of the plan for the weekdays, just like little updates, and then Sunday streams can be longer and in depth, and maybe even writing actual large systems, like we're used to. Anyway, thank you everybody
Yeah,
so
I'll
much for watching.
Yeah, thank you, Sarade. Thank you, Lens. Thank you, everyone.
Hey. Make sure to go to youtube.com/LENSR. It redirects to my channel now, so that's cool. And be sure to check, there's every VOD here of every stream I've ever done, so you should check it out. Be sure to follow on Twitch, that button works, and it will tell you sometimes when I'm going live, but not every time. So be careful about that one. Does anybody here have anything to shout out? It can be a YouTube, a
moment.
GitHub, anything. I'll put a link in the description.
My YouTube in the description because as soon as I start working on Intercept with you guys, I'm going to try to stream it.
What's your YouTube called, Nashiora?
I think it's at Nashiora.
Okay, so
YouTube.com/@Nashiora.
yeah,
But
so
I'm checking.
just be on the lookout for maybe a link in the description or somewhere to a link to Local's channel where he will be doing
I'll hand
more
Lens
stuff.
Compiler Explorer link for the not exactly this, but right above this with just this stuff. Put that in an actual God ball so you can check that out and play around with it.
Fantastic.
I was correct. It is at Nashiora on YouTube.
Hey, that's right. So go to youtube.com/Nashiora. I can't even talk.
Yeah, it does require the @ I'm pretty sure.
We'll get you.
YouTube.
We'll get you there.
Yeah. Anyway, I'll be streaming there.
Check it out for another language in development called Laya, which we may end up being a front end to the
I think that'd be fun.
LCC, the Lenser Compiler Collection. That's right. It's not INTC anymore. We've renamed it.
I was gonna say if we stream only next Sunday, then this is I was gonna say welcome to another episode of C++ Weekly because we have Compiler Explorer open.
No.
Yes. That's so good. That's a great idea.
Could do LCC Weekly.
Sure.
All right, everybody. Thank you so much for watching. I'll see you next time. I'm going to stop streaming. Bye-bye. You all have a great time. I'll see you.